Good morning, everyone. Very good morning, all of you. Welcome to GFG. Welcome to the Network Maha Revision session. In this particular session, we will be discussing the entire network analysis, which is a very important subject for your GATE examination in two sessions. Today, 8 to 12, and tomorrow, 8 to 12, we will be finishing this entire subject. So, those who are in the live, kindly confirm my audio and video, everything is clear for you. If it is clear, we can start the session without any further delay. Kindly respond. If everything is fine, I can start the session. Good morning. Can you respond if everything is fine from my side? My audio is clear for you, video is clear, then we can start. Yeah, thank you. So, in this particular session, as I told, we will be discussing the entire network analysis in two shots. Today, half part. Today, I'll be discussing three chapters and tomorrow two chapters. So, let's start. So before going further, let me introduce myself. If you know me, then it's fine. Otherwise, myself, Vima Shankar. I did my master's from IIT Kharagpur and also I'm pursuing my PhD from IIIT Hyderabad. I have 14 years of teaching experience. I don't want to specify, say more about me because most of you people knows me. I'm there in these online platforms also from past many years and I'm able to mentor many students like you people. And coming to network analysis, I taught many number of batches regarding this network analysis. I can give you the best possible content today. So if you want to join, for the notes and everything, you can scan this QR code and join the Telegram channel. You will be getting all the updates from the Geeks for Geeks. So this is the schedule. I hope you know that marathon sessions come. So today we are doing with the network analysis. And iske baad, tomorrow we will be, not tomorrow, day after tomorrow onwards, we will be starting this one also. That is a PYQ series of network analysis. That is also going to happen. So today and tomorrow you will be having gate before gate, the total mock test. So please enroll to this and give an exam so that you will also get the clarity. So let's start the subject without any further delay. So coming to network analysis, we have, so guys, you understand, if it is a regular class, I can discuss it as slowly as possible because in that particular class, I should explain you each and every basic in a very clear way. But this one is a marathon session, it's kind of a Maha revision. When I'm doing this, I assume you already have some subject and I'm repeating just to revise the things. Even you don't have also maybe like a crash course, it might be helpful, but it will be a faster pace, not like a regular what we discuss in general comprehensive courses. So here in syllabus coming to that network analysis, we can classify into five parts. The first part will be the basics, where I will be discussing like the very basic part of the network analysis. I hope you understand network itself a basic subject and this basic chapter will give you basic of the basic like KCL, KVL, node analysis, mesh analysis, star connection, delta connection, voltage division, current division, series connection, parallel connection. So we may spend some amount of time today on this part. Then I will be dealing with the network theorems and two ports. So most probably today we will be discussing only these three topics and some introduction of the transients. After that, the remaining part of the transient and AC analysis we will be discussing in the tomorrow's class. So mostly you can expect at least 8 marks to 10 marks from this particular subject for both EC and electrical engineering students. So let's continue now. So the first part is basics. So in the basics, quickly we'll go because I assume at least some basics must be there with you. Still, no issue. We will quickly discuss the necessary basics before going for the other relevant topics. So here, the first part we will be discussing is the classification of elements. So in the classification of elements, so any network is made of different kind of elements like linear, non-linear, active, passive, unilateral, bilateral, time invariant, time variant, lumped and distributed. You can see here what is an active and passive element. An element is said to be active if it is what we can say, if it is able to deliver the energy to the external network connected. Otherwise, we can say it as a passive. So resistor, inductor, capacitor comes under passive elements, and your transistor, op amps all comes under active elements. So generally, impedance point of view, if it is a passive element, it will always offer you positive impedance only. If it is a passive element, it will always offer you positive impedance only. If it is an active element, it can offer both positive and negative impedance. Means it might be able to deliver the energy, or it can also absorb the energy. So how the impedance can be positive or negative is, you can say like this. Suppose there is a source. Okay. Suppose the current here is in this direction. So here current is flowing from positive to negative. In this case, this element is absorbing the energy. If the current direction is negative to positive, in this case, this element will be delivering the energy. Okay. So here it will be absorbing the energy. Here it is delivering the energy. In this case, the resistance offered will be, we can take it as a negative. Resistance offered by this element as a load. And here the resistance will be 4 by 2. That will give you 2. Got it? So this will be plus 2 and this will be minus 2. Clear? Okay. So if it is an active element, it can also deliver, it can also absorb the energy, but passive element always absorbs the energy. There is some exceptions like a capacitor, inductor. During the transient period, they can temporarily act as a source and deliver the energy. That is a different case. But for time being, please understand that if the element is able to deliver the energy, it is active. Otherwise, it is passive. It should be able to do it for infinite amount of time. The next classification we can have is linear and non-linear. If your element, why we should study this linear and non-linearity means, if you want to make your network analysis easy, we should have the basic concepts of linearity and non-linearity. Until unless if we are clear with linearity and non-linearity, I mean, we cannot apply the theorems like superposition, Thevenins and Nortons, which makes your analysis easy. So to understand the network is linear or non-linear, very simple rule is its voltage current relationship must be straight line passing through origin for all time. Its voltage current relationship must be a straight line passing through origin for all time. That is the required condition for the linearity. Resistor, inductor, capacitor comes under linear, and diode comes under non-linear element. The next one is a bilateral and unilateral. It is also similar, we can say bidirectional and unilateral. Because I am not spending much time on this very basics, we will discuss more things. The next part we will spend more time and we can discuss more. Bilateral means the voltage current relationship will be, even though current direction changes, it will offer same impedance. For example, you see here, I have an element like this. I have a current I1. I am getting a voltage V1. What is the impedance here is V1 by I1. If the current is reversed, voltage will also get reversed. The ratio will be minus V1 by minus I1. So that will give you plus. Irrespective of the current direction, if impedance remains same, then it is called as a bilateral element. Otherwise, it is called as unilateral element. The next one is dependent on time or independent. Physically, element is present, lumped, otherwise it is distributed. Generally, if it is a regular class, we discuss this concept for 1.5 hours, every single minute detail. But here we are not going through that because it's a quickly, I am revising very basic of the network analysis. Now, I have given the definitions. Later you can revise it from the notes. I will provide you the PDF also. Now, I ask you one question. I want you people to answer this. Can you tell me if it is a straight line passing through origin? If it is a straight line passing through origin, is it linear or non-linear? Those who are in the live can respond. I will be reading your comments. And if you have any kind of doubts also, you can feel free to ask. Okay. Come on, respond. Is it linear or non-linear? Linear. Straight line passing through a origin. So here voltage current ratio will be positive. Here also voltage current ratio will be positive. It's a bilateral. And impedance is always positive, means it is a passive also. So I can say this is linear, passive, bilateral. Suppose in this question, if the VA characteristics are like this. So can you tell me, in this case, the network is linear or non-linear or passive or active, unilateral or bilateral? Come on, respond. Good morning, everyone, once again. Come on. In this case, also it is linear. And here voltage current ratio is negative. Voltage current ratio is negative. So I can say it is active, and you can say it is bidirectional, because for different directions the impedance will remains the same. I can say bidirectional. Now I'll ask you, based on these two, one question. I want you people to answer this. So just tell me the last one, which is interesting. The last one is linear or non-linear, active or passive, unilateral or bilateral. Kindly respond. Last one, linear or non-linear? So you can see here, uh, voltage current ratio, firstly it is linear and also bilateral. The doubt will rise regarding whether it is active element or passive element. Please listen carefully here. Here voltage positive, current negative. You may think, sir, voltage current relation is negative, sir. Negative impedance means I can assume it as an active element. No, we cannot assume this as an active element. Why? Because see, the reference current direction here is positive to negative, fine. But here the reference current direction itself negative to positive. So here we should be careful. Earlier negative becomes here positive, earlier positive will become here negative. So we should be up to this, anybody can answer it easily, but this one you should be careful. You can see here my voltage positive, current negative. You can see here voltage positive means it is the same as polarity given in the figure. Current negative means current is opposite to the direction of assumed in the figure. So minus I means current is not upward, it is downward. So you see here now current is flowing from positive to negative, means it is absorbing or delivering? Absorbing. So here I can say it is absorbing, or impedance is positive. Come here. Here current is positive. Current is same direction. Voltage is negative. Current is positive. Voltage is negative. Voltage will be in the reverse polarity. means it is reverse of what here also the current direction is positive to negative only. So in this case also it is absorbing. So here also absorbing, here also absorbing. What does it mean? It is always absorbing means it is a passive element. So if reference current direction is given in a wrong, different way, you should be careful. Don't blindly follow any rules. That is the logic I want to give you here. So now let's move for the next topic, classification of sources. In any point of time, if you feel any kind of difficulty, if you have any kind of doubt, feel free to ask me. I can be happy to help you. Yes, yes. Raj, right answer. Okay. So now the next part is classification of sources. Uh, Firstly, we can classify the sources into two types, independent and dependent. So we can classify the sources into two types, independent source and dependent source. So independent we can classify as again two types, ideal and practical. Okay. And dependent we can classify as voltage control voltage source, voltage control current source, current control voltage source, and current control current source. Okay. So these are the four variants for the dependent source. So here in ideal again you have two types, voltage source, current source. Here also you have voltage source, current source. The first broader classification is what is independent, what is dependent. So independent source will be delivering the energy to the network on its own. I have a network. The energy given by the source is on its own means it will not create the energy. It will convert some form of energy into electrical form, that is for sure. But independent source delivers the energy to the network on its own. What about dependent? It will deliver the energy by taking from some other independent source. It will deliver the energy by taking from some other independent source. Best example is a transistor, op amp. They will also deliver energy. They will also do the amplification, but without biasing voltage, they cannot do that job. That is what we call dependent sources. Dependent sources can also deliver the energy by taking from some other independent source, by taking from some other independent source. So in independent, you have ideal possibility and practical, voltage also, current also. We will see all of them. So here ideal voltage source is nothing but it is like a ocean. It can suppose if you go for a ocean and you take some water, its characteristic will remain same. You take a bucket or of the water, or if you take any amount of water, it will remain the same. The same possibilities are valid for the ideal voltage source. If you connect an ideal voltage source in a network, its voltage always remains constant. Current is any value. Current can be any value. Current can be positive, current can be negative, current can be zero also. It depends on what you have connected to the network. For example, you can see. Just for example, suppose you have a 10-volt source. You have connected 1 ohm resistor here. How much current you will get here? 10 ampere. For the same 10-volt source, okay. If you connect in this fashion, here I have a 20-volt source and 1 ohm. What is the current you will get in the reverse direction? Here 20 minus 10 upon 1. 10 by 1, how much you get? 10 amperes. So in this direction, it will be minus 10. Suppose you have here 10 and I have a resistor of 1 and another 10. What is the current you will get? 0. Okay. So what you can understand here? Current can be plus 10, minus 10, it can be 0. What does it mean? Means if you have an ideal voltage source with a voltage value Vs, depending on the load you have connected, I will be variable based on RL, but voltage will remain V equal to Vs. voltage will remain V equal to V. V will be Vs. Current can be positive quantity, current can be negative quantity, current can be zero also. So this is what happens with the ideal voltage source. You can see its characteristics is not a straight line passing through origin, means all the sources are non-linear in nature. They are non-linear in nature, and you can see they are unilateral because here current positive, here current negative, ratio will be different. They are non-linear, active and unilateral. Shall we proceed for the next? Shall we proceed for the next? Okay. The next one, we are going very slow. I mean, initially these basics are clear, then we can discuss at the next topics like network theorems we can discuss, and two-port networks. I will quickly revise them. Basics, let's, very basics, we are at the very basic level now. So let's move further, guys. So this is about your ideal voltage source. Similarly, you can have a practical source. So practical voltage source, what happens? You will be having Vs with some internal resistance Rs. Here, I will connect some load. You can see here, let me take this as V, this as I, my drop is I into Rs. Take the loop equation, Vs minus Irs minus V equal to 0. I hope you know how to write the loop equation. Still, we can discuss it when we discuss the KCL, KVL. I can help you with that. So, my V will be equal to Vs minus Irs here. So, in this case, what happens? My I increases, V decreases. Whenever the current increases here, voltage decreases. When current increases, voltage here practically decreases. So, practical source, you will be having this characteristics. With respect to I, my Vs will be reduced. V equal to Vs minus Irs. I hope you understand here. So here one simple thing, like whenever high current flows, the battery terminal voltage reduces. Whenever you start a bike, motor vehicle, or when you start some high current, heavy load, we can say. Whenever heavy load is switch on, immediately the lights will blink for a moment. Why that is happening? Because when huge amount of current flows, the voltage will be reduced. This happens when you start vehicle also. Due to ignition, it requires huge amount of current. After some time, startup is completed, current goes to normal level, voltage goes to normal level, and the bulbs will glow normally. So same thing here. Whenever current increases, the voltage across the terminal voltage of the practical source will be reduced. So this is what we call practical source, where current and voltage are not independent. In the ideal source, voltage is constant irrespective of current. But for a practical source, voltage is dependent on the current. Voltage is dependent on the current. So similarly, we can also have ideal current source. In ideal current source, what happens? Current remains constant. I will be Is. Voltage can be positive, voltage can be negative, but current remains constant. Similarly, we have practical source. Here with respect to voltage, current will be reduced. It will be like Is minus V by Rs. I am not writing this. I will show you this figure. Current source with internal resistance represented in parallel. Here it is simply no internal resistance. Okay. So this is about your practical and ideal voltage and current source, very basic fundamental rules. Okay. Now listen here. So these points I have added in the notes. Whenever you revise the notes, it will be handy for you. If you take dependent sources, so dependent sources we can also call it as linearly controlled sources. What is the alternative name for the dependent sources? We also call it as linearly controlled sources. You can see here. Say this is a voltage source. This is a voltage source which is linearly getting controlled by some voltage value V1. It is called as voltage control voltage source. Here if V1 0, its value will become 0. Suppose K equal to 2, just for understanding. If V1 is 0, you get 0. If V1 is 10, you will get 20. If V1 is 20, you will get 40. If V1 is minus 10, you will get minus 20. V1 is minus 20, you will get minus, and so on. Understand? So with respect to the V1, the voltage across it will be increasing or decreasing linearly. That's why it is called linear controlled source. Voltage controlled voltage source. But so if you connect some resistor here, this source will deliver the energy. But how long it will deliver? As long as this V1 is not equal to 0. So in the presence of V1 only, it can deliver the energy. That's why we call it as a dependent source. That's why we call it as a dependent source. So similarly, we can have voltage is controlling the current source, and current controlled voltage source and current controlled current source. That's it. So these sources are with respect to the VI characteristics, we can say linear, active and bilateral, not with respect to VI, with respect to control variable, I'm sorry. And presence of dependent source, if you have in the network, those networks are treated as active networks. They can deliver the energy only in the presence of at least one independent source. At least one independent source. So let's move for the next. So for understanding your network analysis, the very basic important point is the very important point or very you should be very clear with one thing called as KCL, KVL, node and mesh analysis. Because 90% of the network analysis, whenever you want to solve any problem using network analysis, it is based on your node analysis. So until unless you are clear with the node analysis, you can never understand the network analysis. So many people will think that they know the node analysis, but still they have 1% or 2% doubt. So network node analysis, you should not have even a single doubt. Even 1% also you should not have any doubt on network. I mean node analysis. That is very important. So let us understand what is where we can apply KCL. KCL, KVL. If you want, you can say. Can I apply for any network, or is there any restriction there? I can apply the KCL here. I cannot apply the KCL. So I have given you the networks like linear, non-linear, active, passive, unilateral, bilateral. In all of them, where I can apply my KCL, where I cannot apply my KCL. So where can I apply? Golden Kumar, I don't know that. So without knowing that, I should not say that. Okay, इसका cut off, मुझको पता नहीं इसके बारे में. ठीक है. Score कितना होना इस पे मुझको पता नहीं. चलो. Come on guys, tell me. KCL, KVL are applicable for any lumped electric circuit. KCL, KVL are applicable for any lumped electric circuit. Lumped electric circuit means a network made of lumped elements like resistor, inductor, capacitor, etc. Okay. So we can apply KCL, KVL for any lumped electric circuit. So you can apply it for linear, non-linear, active, passive, unilateral, bilateral. You can apply for any network. कोई भी network में हम apply कर सकते, कोई दिक्कत नहीं. But compulsory it should be a lumped electric circuit. Okay. Where can I apply the KCL? KCL you can apply at the node. Node is nothing but junction. It is a interconnection of at least two branches will give you simple node. More than two branches will give you principal node. So KCL is applicable for any node. It can be simple node or principal node. So what KCL is giving you in a lumped electric circuit at any given point of time, at any node, algebraic sum of the branch currents leaving the node is equal to 0. Algebraic sum of branch currents leaving the node is equal to 0. You can see here. Suppose I have this. In this case, what KCL is saying is, in my network analysis notation, what I will follow is, if current is leaving, I will take positive, current is entering, I will take negative. Sum of leaving currents, I1 is entering, minus I1 will be leaving, plus I2, minus I3, minus I4, plus I5 equal to 0. So you can see I1 plus I3 plus I4 equal to I2 plus I. So what KCL is saying is, in another way, sum of entering currents is equal to sum of leaving currents. Sum of entering currents is equal to sum of leaving currents. So current can be given as rate of change of charge. So from this we can also say so d by dt of q1, q3, q4 equal to q2, q5. I can say d by dt can cancel from both the sides and q1 plus q3 plus q4 equal to charge entering the node is equal to charge leaving the node. Charge entering the node is equal to charge leaving the node. Q is equal to number of electrons into charge of each electron. You can also say number of electrons entering the node is equal to number of electrons leaving the node. So charge entering is equal to charge leaving. We also call it as a law of conservation of charge. Law of conservation of charge. So KCL expresses law of conservation of charge. KCL expresses law of conservation of charge. So let's move. The next one is KVL. Similar to KCL, KVL is also applicable for any lumped electric circuit only. If you are applying network analysis to any network, until unless KCL, KVL are satisfied, KCL or KVL are like Kirchhoff is like a godfather you can take for the network. So until unless Kirchhoff is satisfied, your analysis is not valid. Your analysis will remain valid only when Kirchhoff is satisfied. Okay. So KCL, KVL are independent of nature of elements. KCL and KVL are independent of nature of elements, but they must be lumped electric circuits compulsory. So KVL is saying that in a lumped electric circuit for any of its loop, what is the meaning of loop? Loop means closed path. What is the meaning of loop? Loop is nothing but a closed path. Closed path means you start from one node, end at the same node. Network is closed or not doesn't matter. See, for example, I have this kind of network. Here also I can apply KVL and here also I can apply the KVL. So here it is open, here it is closed, you can understand. So whether the network is closed or open doesn't matter, we can always apply your KVL. Loop means wherever you start, you should end at the same part. Your path must be closed, network need not be closed. This kind of confusion might be present in your mind, that's why I'm trying to clear that. You can see in a lumped electric circuit for any of its loops and at any time t, the algebraic sum of branch voltages around the loop is equal to 0. Around the loop is equal to 0. So let's move further. Here, for example, say current enters from positive, leaves from negative in any passive element. That is the rule here. VR, VL, VC. Take the loop equation here. So when you take the loop equation, always remember In any passive element, current enters from positive, leaves from negative. And in your traversal, negative to positive, if you traverse, you take it as plus. Positive to negative, if you go, you take it as minus. So what is KVL here? V of t equal to VR plus VL plus VC. What is VR? I of t into R. Okay, that we now see here. Voltage is nothing but energy required per charge. Energy required per charge. For moving the charge, you can say. So your W will be WR plus WL plus WC. The total energy equal to sum of individual energies. The total energy is equal to sum of individual energies. It is also called as law of conservation of energy. So KCL is based on law of conservation of charge. KVL is based on law of conservation of energy. Law of conservation of energy, you cannot violate it. So KVL cannot be violated. KVL cannot be violated. So KCL, KVL must be satisfied in any single network, any given network. You can apply any analysis. That analysis will be valid only when KCL and KVL are not getting violated. Not getting violated. So shall we proceed further? Why they? Okay, one question here. Yeah, I will cover every topic of the network analysis in this revision. Okay. The second question is, sir, why they are called lumped? Why they are called lumped? Lumped means physically available. Suppose you see here, this is a device. If you open this device, you can see some elements here. Those elements physically available, they are called as lumped. Suppose there is a resistor here inside this device. That is a physically available lumped. For example, I have this wire. This wire will have some resistance. Wire will have some resistance. But if I open this wire, I cannot show that resistance, which is distributed throughout the wire. This is called distributive resistance. That is called as distributive resistance. So that is the difference. Chalo, let's move further. Now, if you apply KCL and Ohm's law together, because for analyzing any network, only KCL, only KVL, it cannot be helpful. So we should take both of them. If you take KCL and Ohm's law together, it will give you the node analysis. If you take KVL and Ohm's law together, it will give you mesh analysis. KCL and Ohm's law will give you the node. KVL and Ohm's law will give you the mesh analysis. So KCL, KVL are independent of nature of elements, whereas Ohm's law depends on nature of elements. So you cannot apply Ohm's law for the active networks. Ohm's law is applicable only for passive. So in this point, I want to give you some explanation. Conceptually, it is very important. What is Ohm's law? V equal to IR, R equal to V by I. R equal to V by I. Okay. So I have a 10 volt source. I have 10 ohms resistance. 1 ampere here. So voltage is same here. Voltage is same here. 10 by 10. How much current you will get? 1 ampere. This is 1. This is 1. This will be 2. And what is the input resistance of this network is input voltage by input current, that is 5 ohms. Now, if you take the resistance can also be calculated as input resistance can also be calculated as this resistor. How much? 10 parallel with the resistance of the source. What is the resistance of the source? I am not saying internal resistance, simply I am saying resistance offered by the source. It is given by its voltage upon current. So 10 parallel with 10 will give you how much? 5 ohms. 10 parallel with 10 will give you 5 ohms. Both are same or not? Now I want to say, sir, here you said it is applicable only for Ohm's law cannot be applied for the sources. So R equal to V by A is valid only for passive. So here 10 by 1 equal to 10, correct. But here also 10 by 1 equal to 10 is getting satisfied, right? If I substitute this 10 here, I am getting 5 ohm, which is the valid answer. If I substitute here this 10, I am getting 5 ohm, which is valid answer. So this source is also accepting Ohm's law. Can you answer this? This source is also accepting Ohm's law. Source को भी Ohm's law applicable है क्या? Normally V R equal to V by जो मैंने बोला that is applicable only for passive. But यही पे मैंने active को भी I have applied that V by I logic. I have applied V by I logic for the active element also. So how is it possible? Is it true that Ohm's law is applicable for active elements like sources also? No. Listen here. I will tell you. Now 10 I have taken 10 here, 10 here, and I have taken 1 here, 1 in the reverse direction. Now what happens? 10 by 10 will give you 1 ampere. This will be 10 and this will be 1 is coming, 1 is leaving. What is this current? 0. Now what is the input resistance? 10 by 0, infinite. So here, what is the RS? Arrow direction you see negative to positive. So minus 10 by. Okay. So now what is your input resistance is equal to 10 parallel with minus 10. If you take 10 into minus 10 by 10 minus 10 will give you infinity. True or not? So I can understand here what is that you should understand Ohm's law properly. What Ohm's law is not V equal to IR. Ohm's law is originally V is proportional to I, V equal to IR, and R must be constant. What Ohm's law is saying, R must be constant. So you observe here, R is a constant. For a 10 ohm resistor, input is 10 volts, 100 volts, 1000 volts, any value, the resistance is 10 only. But for this source, if I change the input, my resistance is getting changed. If the input is 10, I am getting resistance equal to 10. If input is 100, I'll get the resistance equal to 100. If input is 1000, my resistance will also vary. R is not constant for the source. That's why we say sources will never obey Ohm's law. R will never be constant and V and I will never be proportional. Clear? Chalo, let's move further. So while applying the node analysis to any network, generally we follow 3 steps. First step is we identify how many nodes are present in the network. Second is we should take one node as a reference node. For assigning the node voltages, always we should speak any node voltage should be with respect to that node only. Then the third point is we should write the node equation by writing KCL first. Always keep it in your mind while writing the node equation. KCL plus Ohm's law will give you node analysis. KCL and Ohm's law. While writing KCL, generally in node analysis, where you find the difficulty, sir, what we call current direction. When you are assuming current direction, sir, which voltage is more, which voltage is less, how can I know that, sir? So simply blindly assume all currents are leaving, then never you get any confusion. Sir, if you assume all currents leaving, is there any problem? No problem. If any current is entering, you should take it as your answer might be negative, but blind way without confusion is while writing node equation, assume all currents are leaving. I will show you. For example, this is my network. Okay. How many nodes are present? Nodes means take only principal nodes. This is 1, 2, and 3. I will take this node as a reference. With respect to node V1, with respect to this node V2. If I ask you what is this node voltage, we should say with respect to ground only. Means this voltage plus this voltage. Never say immediate voltage. Okay. Then suppose I want to write the node equation at node 2. What is the process is? First, assume all currents are leaving, because it will avoid confusion. Write KCL. Is it okay? IC plus IL plus IR equal to 0. Done. Then, what is the current in the capacitor formula? C into d by dt of, when it is leaving, assume this current is more than this one. That will give you the leaving current plus current in the inductor formula 1 by L integral voltage across it V2 minus 0 plus current in the resistor. Again, always potential difference, this voltage minus this voltage by this one. Always you take this minus other only, that will give you leaving current. V2 minus V of t by total resistance R2 plus R1. This is how you write the node equation. Suppose if you have one more resistor, you take R2 plus R1 plus R3. If these polarities are reversed, then V2 plus V of t you should get. Similarly, if I ask you node analysis at the node 1, just tell me what is the node current entering here. I of t is entering. This current is V1 by R1, and let me assume this current as IC dash. So I of t is entering, leaving current is minus I of t plus, I am writing direct KCL and Ohm's law together. Sum of the leaving currents equal to 0 plus IC1 equal to leaving from V1 C into d by dt of V1 minus V2 equal to 0. Why V1 minus V2? You may get the doubt. Sir, why you take IC1 here? Why can't you take IC is entering? You take my IC is entering. What is leaving current? Minus IC. Again, you should take minus of this equation will give you, instead of V1 minus V2, V2 minus V1, you will get V1 minus V2. So any method will give you same. So blind way to write the node equation is your particular node minus other voltage by impedance, right? So this is about your node analysis. Similar to node, we can also have mesh analysis. So in the mesh analysis, the same process. First, there node analysis, we identify number of nodes, assign the node voltages, write the node equations. Here, identify the number of meshes. Mesh and loop are different. I will explain that. Meshes, assign the mesh currents, write the mesh equations. Identify the number of meshes, assign the mesh currents, and write the mesh equations. In case of at any point of time you have any kind of difficulty like sir, I'm not clear with this point, I'm not clear with this point, like that, if you have any kind of difficulty, feel free to ask me. I'm happy to explain you again. I'm happy to clear the doubts. Okay, chalo, let's move here, the mesh analysis. So here, firstly, listen. Mesh analysis is applicable only for a networks called as planar networks. What are planar networks, sir? If the network you are able to draw on a two-dimensional plane like this without any cross upon each other. You see here there is a crossing, right? You draw it. You draw it in any way. You cannot remove this crossing. This is what we call non-planar network. Here there is a crossing upon each other, but you can remove it, right? I can draw the same figure. If crossing can be removed, it is a node, not a crossing. If this crossing means one upon another branch is there, removed, then it is called as planar. If you are not able to remove, then it is called as a non-planar network. Mesh analysis is applicable only for planar networks. We cannot apply the mesh analysis for the non-planar networks. So let's move here. Now, let us understand the difference between mesh and a loop. You see in this figure, this is a loop, this is also a loop, this is also a loop, this one is a loop, and also they are meshes. L1, L2, L3, L4 are loops and also meshes. Any closed path is a loop. It is also a mesh here. But if you combine these two, this will be loop, not we cannot इसको loop बोल सकते but not mesh. We can say this as a loop. Closed path, कोई भी closed path को loop बोल सकते. Any closed path is a loop but not a mesh. Mesh के अंदर you should not have any other loop. Mesh should not have any other loop. Why that is required is to avoid redundancy while solving the problems. Mesh should not contain any other loop inside it. So if you want to write the mesh equations also the same story, I will show you just quickly. Then we will uh, see 1-2 questions. Let me take a simple network. So this is my network. For this network, I want to apply mesh analysis. Let us see how can I apply it. Firstly, how many meshes are there? This is one mesh, sir. This is one mesh. We should assign the mesh currents in clockwise direction. So current enters from positive and leaves from negative. This is the mesh current. This is the mesh. Okay. So let me take this voltage as VR2, VC, VL. Okay. First, we should apply mesh 2. I am writing for the mesh 2 equation. How do you write? Process is same. First, we write KVL. Write the loop equation positive to negative minus VR2 and positive to negative minus VC, positive to negative minus VL equal to 0. This equation. Then what is VR? Current I of t into R2. What is current and voltage across the capacitor? 1 by C integral same current I2 of t dt. Positive to negative minus what is voltage across inductor is L into d by dt of current. But you see here two currents are flowing. One current is I2, one current is I1. They are flowing in opposite direction. But when you are in the mesh 2, your reference is I2 only. So you should take I2 minus I. Similarly, if you want to write the mesh equation for the mesh 1, negative to positive V of t, positive to negative minus I1 of t into R1, and again positive to negative. Here, when you are in the mesh 1, just write reverse. L1 into, L into d by dt of I1 minus I. So this is how you write the mesh equations. KCL, Ohm's law, KVL and Ohm's law will give you mesh analysis. KCL and Ohm's law will give you the node analysis. Now let us try to solve this simple question. Suppose examiner has given this current as 2 ampere. Can you find E and I? Can we find E and I? Okay. Please give a try. Tell me the answer. I will just give you 1-2 minutes of time. You can give a try. Come on, guys. Please find your E and I from the given information. Why they are called E and I? You can see here, this current is already given by examiner. Why? How to find? What is the 2 into 4? How much it is? 8. Here also you will get 8. Right? Parallel voltage is the same. Now 8 by 1, how much current you will get? 8 amperes. Then 8 plus 2. Total current will be here 10 amperes. So from the given information, this voltage is 10. So 10 into 1, what is the drop you'll get? 10. Okay. Yeah, whether you use node or mesh, the answer should remain same. That is the required condition for sure. So yeah, you can tell me what is this voltage? Here 10 and 8. I just assume this as V by loop equation. V minus 10 minus 8 equal to 0 or V equal to 80. Right. So 18 by 6, 3 amperes. So this is 10 and 3. This will be 13 amperes. Okay. So this will be 13 volts. Take the loop equation. E minus 13 minus 18 equal to 0. E will be equal to 31. And I will be 30. So how I have solved this question? Examiner has given one simple information, that is this current. I use this information to find this voltage. Parallel voltage is same. Then voltage by resistance will give you current. Add them, you will get this current. Then into resistance will give you this voltage. Add them, you will get this voltage. By resistance will give you current. And then add them, you will get the input current. Like that we can find the response. So just a moment. Let us try to solve the network by using node analysis. By using node analysis, let me give a try to find what we call Vx. So you can also give a try. Try to find Vx from the given information. Try to find Vx from the given information. Tomorrow also we'll be having the class same timing, 8 a.m. to 12 p.m. So don't worry about waking up in the morning and all. So if you want to quick revision, definitely these sessions will be very much helpful. So come on, tell me guys, the network shown in the figure, find the value of Vx. Just apply node analysis and try to find Vx. Okay, I'll do it. Very simple question here, but I want to give you one concept based on this. So let me take any node as a ground. Ground is just your reference. I'm taking this node as my ground. So this node voltage will be Vx. Okay. So let me apply the node equation by nodal analysis. Listen carefully. Vx minus 0 by resistance 1. Vx minus 6 by 1. What is the leaving current here? 2Vx. I don't mind about this resistance. Why? Because whenever some current is, what is the node equation is sum of currents leaving the node. So this voltage minus this voltage by resistance, this voltage minus this voltage by resistance, and this current leaving plus this voltage minus what is this node voltage, because I am taking ground. any node voltage to be with respect to ground. So if it is 0, this will be minus 4. So Vx minus this voltage minus 4 will give you 4 by 2 equal to 0. So take the LCM here, Vx 2Vx 2Vx minus 12 plus 4Vx. So 9Vx equal to 8. You will get Vx equal to 8.9. Now you may get the doubt, sir, why you have taken ground here? Nothing in it is not specified anywhere to take ground here. Can we take the ground at some other node like this here and solve the same question? Yes, you can solve the question by taking ground at some other node also. So let me show you that. So from this node, what is this node voltage? 4. And from here to here, the node voltage will be Vx plus 4. Because this is ground with any node voltage to be specified with respect to ground. Now what I want to prove is, if you take any ground, your response or currents will remain same. Okay. So let me find Vx now. So Vx plus node voltages will change, but current will remain same. Voltage difference will remain same. So Vx plus 4 minus 4 by 1. Vx plus 4 minus 6 by 1. Vx plus 4 minus 6 minus 4 plus 2Vx plus Vx plus 4 minus 0 by 2. Now what do you get here? Vx minus 6, 2Vx plus Vx plus 4 by 2 equal to 0. Take LCM. 2Vx minus 12, 4Vx, 4, 8, 9 Vx equal to 8 and Vx equal to 8 pi. So what is your Vx? 8 upon 9. 8 upon 9. Okay. So you try by any method, whether you go by this method or this method, you got the same answer or not. My Vx will remain same in either case. So the no ground can be taken here or here. The what we call the voltage drop will remain same. So can you tell me this answer? In the circuit shown in the figure, R is a variable quantity. R equal to 20, I got the current equal to 2. When R is 40, can you tell me what is the current? Can you guess what is the current I? What is the first statement? When R equal to 20, I equal to 2. The second statement is, if R equal to 40, what will be the current? R equal to 40, what will be the current? R value will affect your current, or R current is independent of R? R can be any value, your current will remain same. You can see here, this R value can be anything. My current here will be 4 only. R is 0, R is 10, R 20, R 40. So, and this, because he has already given I for one value, the current I will remain same for any value of I. Any value of R, I will be same. Because the resistor in series with the current source is of no meaning, you can neglect it in the analysis. So there is one concept called supernode. There is one concept called supernode. Let me explain that, then we can proceed for the next. Okay, so listen carefully here. This is my network. For example, this is my network. Okay, I want to write the node equation here. Sir, 9 is entering minus 9, V1 by 1 by 2, V1 minus V2 minus 5 equal to 0. Right? Minus 9, V1 by 1 by 2, V1 minus V2 minus 5. But resistance is not present. I cannot find the current directly. When resistance is not present, I cannot find the current directly. So what I can do here is, I should join these two nodes and form a super node. What is that? Super node. When do you form the super node? When you have a ideal voltage source between two nodes. Whenever you have an ideal voltage source between two nodes, we can form a super node. We can form a super node. So what is the concept of super node is, join these two nodes and write the equation combinedly. Minus 9 V1 by 1 by 2 V2 by 1 by 6 minus 4 equal to 0. So 2V1 plus 6V2 equal to 13. So what I need to do? Write the equation combinedly for both the nodes. Okay, then here, if this is V1, this is V2, take the loop equation. Inside super node, always apply KVL. V1 minus 5 minus V2 equal to 0. What is V1 minus V2? 5. You can solve them, you'll get V1 equal to 5.375 and V2 equal to 0.375. Got it? Understand? Now, my question is, can we this is supernode concept, you might be knowing it, but my question here, I am asking you, can we apply this if it is not a voltage source, if it is not a ideal voltage source, if you have some element between V1 and V2, this supernode concept can be applicable there or not applicable? I want your answer. Come on guys, respond. Raju, you can ask it at the end of the session, I can help you. So come on guys, respond. My question is clear for you. Can I apply this technique? Can I apply this technique if you don't have a voltage source between the two nodes? Just say yes or no, that is sufficient. Just say yes or no. Can I apply if there is no voltage source between the resistor, between the nodes, if there is no voltage source, in that case also I can apply it? Yeah, we can apply it irrespective of the element. In between, if you have a resistor also, you can apply it. In between the nodes, you have a resistor also. In that case also, you can apply it, because this is nothing but KCL only. I am writing KCL in a different way. See here, I will clarify that. You can see, I can write this current as I. Then this current is I1 plus I2. Originally, what is KCL here? Minus 9 V1 by 1 by 2 plus I equal to 0. But because this I is unknown quantity for the voltage source, instead of I will write I1 plus I2. So that is what we have done here. Instead of writing I directly, we are writing I1 plus I2. Because we are not violating KCL, whatever we have applied here, it is applicable for any network, no doubt in it. We can apply it for any network, whether it is but it is useful when you have a voltage source, because you don't know I. If you have a resistor, you can find I directly. In that case, it is not necessary. Otherwise, this technique is applicable in any network. Okay, it is nothing but KCL. Similarly, similar to super node, we have a super mesh also. Similar to super node, we have super mesh also. Then what is super mesh? Super mesh is ideal current source between the two voltage sources. Then we cannot write the equation directly. Then you can combine both of them and write the loop equation. Okay, you can see here. Suppose this is my network. I want to find I1, I2. I cannot find I1, I2 directly here. I1 and I2 impossible to find directly. So what to do? 10 minus, combine both the nodes, write the single equation. Combine both the loops and write a super loop, super mesh we can say. 10 minus 2 I1 minus I2 equal to 0. So 2 I1 plus I2 equal to 10 will give you one equation. Then how to get the second equation is very simple. At this node apply KCL. What is this current? I2. What is this current? I1. So what is the KCL? What is the KCL here? 7 is entering the node, so minus 7. I1 is leaving, I2 is entering. So I1 minus I2 equal to 7. Equation 2. I1 minus I2 equal to 7. Equation 2. Okay. So if you solve 1 and 2, you will get I1 and I2. Got it? That's it. So next, so one very important concept we need to discuss in the basics is in the equivalent circuit, star delta conversion. What is the first last, this is I can say, firstly we started with the basics, classification of elements, sources, KCL, KVL, node, mesh analysis. Quickly I have revised. Now we are starting equivalent circuits. Here what we are going to discuss is series connection, parallel connection, star connection, delta connection, voltage division, current division, and some source transformation techniques. Then we will discuss some part of what we call energy power calculation. That finishes your first chapter. That finishes your first chapter. Then we'll move for the network theorems also. So let's move here. Star delta conversion. Suppose मेरे पास एक star network है. Suppose I have a star network. I want to convert this into a delta network. How can I do this? I have a star connection. I want to convert into a delta. How can I do this? Very simple. Star say I can convert into its equivalent delta, and delta can be converted into its equivalent star, which will make my analysis easy, or sometimes it will make my network to simplify easily. So star को delta पे convert करने के लिए what is Z1? Z1 is given by ZA plus ZB, ZA, ZB by ZC. You can also write shortcut formula sum of knowns. जो रेसिस्टेंस इनको नजर आ रहा है, ओके, वो रेसिस्टेंस को ऐड करो प्लस their product upon remaining. So what is Z2? Sum of the knowns, that is ZB, ZC plus their product upon remaining. Similarly, what is Z3? Sum of the knowns plus their product upon the remaining. Okay, this is how we can convert a star network into equivalent delta. Similarly, if you have a delta, you can convert into star. आपके पास एक delta है तो अब इसको भी आप star जैसा convert कर सकते हैं. कैसे करना? How we can do delta to star is ZA is equal to Z1 Z3 by Z1 plus Z2 plus Z3. It will be product of knowns by total. So can you tell me ZB क्या होता है? What is ZB? Z1 into Z2 by what about ZC? ZC. Z2 into Z3 by total. Z2 into Z3 by total. Suppose if the network is balanced, star or delta, कोई भी balanced connection, balanced star or balanced delta, कोई भी ले लो. In both the cases, that is if ZA equal to ZB equal to ZC equal to Z. उस केस में क्या होता है? If ZA, ZB, ZC equal to Z, all of them are equal. In that case, what is your result? What is your result? Z1 equal to Z2 equal to Z3. Can you tell me? If all of them are equal, what is Z1? Z1 equal to Z2 equal to Z3 equal to Z plus Z square by Z will give you how much? 3Z. So star to delta conversion will increase the impedance by 3 times and vice versa. Star to delta conversion will increase the impedance by 3 times and vice versa. Delta to star will reduce the impedance by 3 times. Okay. Let's move. Can you tell me what is CA, CB, CC here? Determine CA, CB or CC. Come on, CA, CB, CC. I'll tell you. Listen. What is CA? Whenever you have capacitor, always be careful. Don't blindly apply this formula, sum of the knowns plus their product by remaining. Galat hota hai. That is wrong. So how you can apply, what to do here is whenever capacitor Z equal to 1 upon J omega C. Because of this, capacitor comes, be careful. Sum of the knowns plus their product. Similarly, what is CB? 1 by 2, 1 by 3. Similarly, what is CC? 1 by CC equal to. Okay, sum of the knowns plus their product by remaining, but capacitor you should take 1 by C. Our capacitor volta formula will work. That is, instead of star delta, you apply delta star. Product of knowns by total. You will get the answer. CA will be equal to how much here? 1 by 3. Calculations you do. Okay. So that is basic about star delta conversions. So let's move further. So can you solve this question? Very simple. Based on what we have discussed in the previous case, can you give a try and find C3? Can you find C3? Please try to find C3. Identify C3. Find C3. Calculate C3. Come on, guys, respond. C3. So whenever you, see, this is the question called as a balanced bridge. Whenever the bridge is balanced, what is the required condition here is, we call it as a Wheatstone bridge. For a balanced bridge, Z1 upon Z2 is always equal to Z3 upon Z4. When bridge is balanced, the shunt current will be equal to 0. You can neglect the shunt elements. So Z1 upon Z2, 1K by 3K equal to Z3. Again, capacitor comes, be careful. Whenever capacitor comes, we should take 1 upon J omega C3 by 1 upon J omega C4. So you should take the ratio C4 by C3. So my C3 will be equal to 3 times C4. So 3 times 35. That's it. Okay. Chalo, let's move for the next question. So based on whatever we have done in the previous question, can you identify the value of the current source IS? Can you identify the value of the current source IS? Please give a try and try to solve to find the value of the current source IS. Here also examiner has given that the network is balanced, bridge is balanced. When the bridge is balanced, can you find the value of current source IS? Here the bridge is balanced. Can you find the value of current source IS? So bridge balanced, what is the required condition? Z1 upon Z2 equal to Z3 upon Z4. When bridge is balanced, Z1 by Z2 equal to Z3 by Z4. But here, unfortunately, this is not impedance. Here you have a voltage source. Then what is the rule you should apply? How can I find the solution? How can I find the response here? Bridge is balanced, but the elements are not impedances. Elements are not impedances. Elements are voltage sources. So guys, listen carefully. Whenever the bridge is balanced, the shunt current will be equal to 0. Shunt current will be equal to 0. So the node voltage here and node voltage here must be same. say V1 must be equal to V2. This is the required condition. Even the elements are not impedances, don't worry. So what is this voltage here? 2. This is also, if this is 9, this is also 9. Just by loop equation, assume this drop equal to 0. Now, 9 upon 3k will give you 3 milliamperes. 2 upon 1k will give you 2 milliamperes. Because no current is flowing in the shunt in the balanced case, this 2 will come in this way and the same 2 will leave here. And this will be IS. So, can you apply the KCL here? Entering current is IS, leaving current is 3 milliampere, entering current is 2 milliampere. So, my IS will be 1 milliampere. My IS will be 1 milliampere. Okay, balanced bridge, shunt current 0, no drop here. Then you can see this voltage will be same. This voltage will be equal to this voltage. From that I can find the response. If you want, I can do like this also here. If this current is 0, what is this current? 3 milliampere. Okay, got it. Fine. Now, I told whenever bridge is balanced, Z1 upon Z2 equal to Z3 upon Z4. Can I say that condition is true here also? Because here voltage source is present, resistor is not present. यहीं पे केवल source दिया ना, resistor नो नहीं दिया. But source को भी resistor जैसा हम assume कर सकते हैं. You can also assume source as a resistor and find the Z1 by Z2 equal to Z3 by Z4 condition. Is it true or not? Let me check it. So here Z1 equal to 3K. I will assume Z2 is nothing but its voltage current ratio. What is the voltage? 2. Current 3. Arrow direction minus. So 2 by 3 milliamperes. Next, what is Z3 here? Voltage by current ratio. Voltage is 9. Current is arrow direction. You should check negative to positive. So minus 3. Okay. And Z4 equal to 1K. 2 not 2. So now I want to prove that my Z1 by Z2 always equal to Z3 by Z4 in the balanced bridge condition. So Z1 by Z2 kitna? 3K by equal to Z3 by Z4. 9 by minus 2 by 1. So is it correct or not? Minus 9 by 2 equal to minus 9. Both the condition, it is satisfied or not the condition. So, I mean the concept whatever Z1 by Z2 equal to Z3 by Z4 is still valid here also. But you should assume this resistance of this source is always voltage current ratio with arrow direction negative to positive is minus, positive to negative is plus resistance. Okay, shall we proceed further, guys? So the next important concept we can discuss is series and parallel connection. When do you say the elements are connected in series? When do you say the elements are connected in parallel? If the current through both the elements are same, then the elements are said to be in series. If the voltage across the two elements is same, we can call them, they are connected in parallel. Say for example here, so my question to everybody, please carefully listen and give me the answer. I want you people to answer this question. Come on. Is there any two elements which are connected in series here? Is there any two elements which are connected in series here? Are there any two elements which are in series in this particular case? Are there any two elements which are in series here? Like maybe R1, R2, R3, R4, like that. Why I am asking this is, it is important to know the connection, because then only you can identify what we can say. If you understand the connection, then it will be easy for you to what we call apply the voltage division, current division, etc. Principles can be easily applied. Come on, guys. Okay, listen. If you see like that, you may think there are no two elements which are connected in series, sir. But small change. I will redraw the same network. I will redraw the same network in a different way like this. I will take R1, R2 and V1. This one will be R3. I will just redraw this network in this fashion. Come on, guys. Now listen here. Now carefully listen here. If you observe in this case, yes, sir, it is correct, sir. R3, R4 are in series. I can add them. Yes or no? Because if you divide here the current, I will divide into I1, I2. This I2 will get divided into I3, I4. Then I4 will come, I3 will come, both of them will get added and you will get I2. So the current I2 is the same in R3 and R4. You can say logically R3, R4 are connected in series. So sometimes you may not be able to visualize the elements are in series or parallel. So you should check by current is same or not, voltage is same or not. Based on that, we may say the elements are series or parallel. Okay. So now when the elements are in series, you have voltage division principle. When the elements are in series, we have voltage division principle. What is that? If you have two elements like this, what is V1? V Z1 upon Z1 plus Z. What is V2 is given by VZ2 by Z1 plus Z. Here V1 upon V2 is Z1 upon Z2. If Z1 equal to Z2, V1 equal to V2 equal to V by 2. This is what we call voltage division principle. When the elements are in series, current is same, but voltage will get divided as V1, V2. I'm not deriving it because it is a quick revision session. So V1 equal to VZ1 by Z1 plus Z2. V2 is VZ2 by Z1 plus Z2. Now, similarly, we have parallel connection current division principle. So you have Z1 here, Z2 here. In parallel, voltage is same, but current will get divided into I1, I2. So I1 is equal to I into Z2 by current into opposite by total. Here what is I1 upon I2 is given by ulta Z2 upon Z1. Here also be careful, listen carefully. Here, if you want to expand this formula for n number of elements, total current into that particular admittance by total admittance. Here also, if you can extend this formula for n number of elements. If you want voltage across one element, total voltage into that particular impedance upon total impedance. Here always be careful whenever capacitor comes, because capacitor reactance is 1 by j omega c, you will get the formula will be reversed. Z should be 1 by c. For capacitor, you should take 1 by c. Inductor resistor, you can take directly R, no problem. Okay. So this is about your voltage and current division principles we can apply in for series and parallel connection. Now try to solve this question from the given information. This is the figure given. 1 ampere is flowing through the 2R. I need to find the current I. Please give a try. Whether you get the answer or not, no problem. From the given information, whatever we have discussed just now, you will be able to answer it. So please try to find the current I in the resistor R. Try to find the current I in the resistor R. Good morning, Harsh. So please give a try. Come on. It's a doable question. You can do it easily. Examiner ये information दिया. Current through the 2R is 1 ampere. Okay. So let us take this node as X, this node as Y. So between X, so if it is grounded, this is also Y. If the elements are between same set of nodes, we can call them as parallel. We can call them as parallel. So between X and Y, you have 2R, current is 1 ampere. Between X and Y, you have 2R, current should be same. Because R1 by R2 equal to I2 by I1 by using current division principle. Otherwise, what is the drop here? 1 into 2R is 2R. 2R upon R, how much current will flow? 2 ampere. This is 2 ampere, this will also be 2 ampere. So total, this, if it is 1 ampere, this is also 1 ampere because voltage between them is 2R. Here also 2R by 2R is 1 ampere. So 2 plus 1, how much current will get? 4. So 3 into 4, how much current will get? How much drop? 12 R. Let me take this drop as I into R and take the loop equation here. What is KVL? What is KVL? Negative to positive 12 R. Positive to negative minus I R. And positive to negative to positive plus 2R. So 14 R equal to I equal to 14 amperes. I'm saying any answers? No. Okay. So I equal to 14 amperes. So examiner has given this information. From this, what is the drop? 2 into R. 2R into 1 is 2R. 2R by R is 2 ampere. Same 2R is the drop here. 2R by 2R will be 1 ampere. 1 plus 2 KCL will give you 4. 4 3 is how much? It is 12R. So 12R plus 2R will give you here 14R. 14R is equal to IR. R equal to 14. I equal to 14. So let's move for the next. So the next important theorem we can discuss is Tellegen's theorem. So Tellegen theorem ये बोल रहा है, कोई भी network ले लो, इसमें at any given point of time, algebraic sum of what we call powers at any instant is equal to 0. That is, the power delivered by some elements in the network is equal to power absorbed by the remaining elements in the network. Power delivered by some elements in the network is equal to power absorbed by the remaining elements in the network. So you can see if the sources, if you see a source, whether it is delivering or absorbing, how can I find it? Based on the current direction. If current direction is positive to negative, मेरा source absorb कर रहा है, negative to positive, मेरा source deliver कर रहा है. So if the based on that we can say whether it is delivering or absorbing. Passive element हमेशा क्या करेगा? Passive element always it will be absorbing the power only. So passive element always absorbs the power, but active element can be absorbing, can be delivering. Based on the current direction, we will decide it. So if any given network is given, always we can say power delivered is equal to power absorbed. That is specified by the Tellegen's theorem. You can see here. Suppose, just a minute. Yes. Let us try to find in this question how much power is delivered by the dependent source. So using Tellegen's theorem. So you can see source means whether it is independent or dependent. Source means active element. It can be delivering or it can be absorbing. We will see how to find it here. Firstly, from the given information, what is Vx? 20. So this will be 20 upon 5, which is 4 amperes. So let me take this node voltage as V. I don't know. Let me assume this as V. I'm just assumption. So what is the node equation here? V minus 20 by 5, V by 5. 4 ampere is entering the node, so minus 4 equal to 0. So V minus 20 plus V minus 20 equal to 0. You will get V equal to 20. So from the given information, I am able to find my V equal to 20. Current direction is where to where? Negative to positive. Okay. So this is delivery. How much power is getting delivered? Voltage into current. 8. So if you calculate the power absorbed by the remaining network is equal to power delivered by this network. For example, in this question, if this is also 20, okay, how much 20 by 5, how much current will flow? 20 by 5, 4. This is 4. Then what is this current? 0, because KCL satisfy this current should be 0. So in this case, this one is neither delivering nor absorbing. This one also not delivering, absorbing. This will be absorbing. How much it will absorb? Voltage into current 80. How much delivered? 80. Any network, power delivered is always equal to power absorbed. Here both the sources may be able to deliver it. One source may be able to deliver, another absorbing, one delivering, one neither nor. All are possible. All are possible. So let's move for the next. So in equivalent circuits, another important concept is capacitor with multiple dielectrics. Capacitor with multiple dielectrics. Suppose if the capacitor dielectric medium is divided into parts like this, it is equivalent to two capacitors connected in series. That is, the distance between the plates D is divided into D1 and D2. If the length is getting divided, then we can connect them as a parallel connection of two capacitors. That's a different case. Now, what is C1 here? Epsilon 1 area of the plate by distance D1. What is the capacitance? C2 epsilon 2 A by distance D2. In this particular example, my length is same in both the cases. Length of the plate will remain same, means area is same. Distance D1, D2 are same. So, C1 by C2 here is epsilon 1 by epsilon 2. Epsilon 1 is E naught into ER1. This one is E naught into ER2. What is ER1 here? 1. ER2, 4. C1 by C2 equal to, I can say V1 by V2. No. For capacitor, C1 by C2 hamesha equal to V2 by V1. For capacitor, C1 by C2 always equal to V2 by V1. This will be V2 and V1. Okay. So can I say here from the given information, my V2 equal to V1 by 4, my okay. So can you tell me what is the question here? So he has given the total capacitance is filled with half glass and half air dielectric medium, and he has given the dielectric strengths as 1 and 4. Then what is the condition here? He asked the breakdown voltage. Firstly, for air, what is the breakdown voltage? VBD1 is its dielectric strength. How much? 30 kilovolt per 1 centimeter into what is the distance here? Half centimeter. 15 kV. For glass, what is the condition? 300 kV into the distance is how much? 0. So from the given information, what I can obtain is my V1 will be, I can give my V1 is equal to how much maximum? 15 kV. My V2 will be V1 by 4. Even though I can give my V2 equal to up to 150, but there is a restriction here. My V2 should be equal to V1 by 4. So total V can be V1 plus V2 is how much? 18.75 kilovolts. So can I give more than this voltage? Means if you give more than this voltage, second capacitor can withstand, but the first capacitor cannot withstand. So overall breakdown of this combination is equal to 18.75 kilovolts. 18.75 kilovolts. Yeah, Harsh, you can get this PDF from the Telegram channel I have specified in the starting part of this session. There you will be getting it. So shall we proceed further, guys? So the next topic we can discuss is source transformation. Before that, I want to give you one wonderful question. I want to check how many of you are able to do this question. So give a try, guys. Can you give a try and solve this question? For the given circuit, can you find the state equation? नेटवर्क दिया, इसका स्टेट इक्वेशन लिखना पड़ेगा. Okay, from the given information try to find the state equation of the given network. It's a very good question. You can take 1-2 minutes and give a try. If you're able to answer it, it will be very your network analysis ka what we call preparation is going good. Normal networks, node equations, everybody can do it. This is a special case. I want you people to answer this. Please give a try, guys. Come on. We are almost halfway through. बीच में मैं 5-10 मिनट ब्रेक देता हूँ, कोई दिक्कत नहीं. Then again we can start. So first you try this question. Please try. Okay. Anybody, any answer? Chalo, I will do it. So it's an interesting question. Okay. So please listen here carefully. So for the given circuit, what we need to find? The correct state equation. Right, we can do it. Firstly, at this node, this is V, right? This one will be V by 1, I2, I1. This will be 0.25 C dV by dt. Right. At this node, just write KCL. What is entering current is I1. Leaving current is 0.25 dV by dt plus voltage V. I2 is entering I2. Okay. Now, can you take this dV by dt other side? Then dV by dt equal to remaining all other side. So you take minus 4V plus 4I1 plus 4i2. Is it okay, this equation? My dv by dt equal to, just take it to the other side, remaining all other side, minus v plus i1 plus i2. 0.25 you take it other side, 1 by 4. It will give you 4 into something. Okay, this is one equation. Next, the second equation here is at this node. I1 is entering. This current is given as I. Because the voltage across inductor is L di by dt, 0.5 di by dt. This one is I1 minus I. So can I write like this? I1 minus I into 2. This voltage drop equal to 0.5 into di by dt, perfect, plus V. Okay, now this voltage plus this voltage equal to this one. Expand this. Minus 2i my plus, sorry, minus 2i plus 2 times I1 equal to 0.5 di by dt plus V. Take it other side. Yeah, you take it other side. Minus V minus 2i plus 2i1 equal to 0.5 into di by dt. So what is di by dt? You take this minus 5.5 is 1 by 2. Take it to the other side. Minus 2v minus 4i plus 4i1. Okay. So finally the conclusion here is dv by dt equal to minus 4v plus 4i, sorry, minus 4v plus 0i. If I am not wrong, this is I, right? Not I1. Sorry guys. This one is I, right? So minus 4v plus 4i. I1 is not present. So 0 times I1 plus 4 times I2. di by dt is minus 2v plus 4i plus 4i1 plus 0 times I2. So you can write here in the matrix form like this: d by dt of v by I equal to minus 4, 4, minus 2, 4 into v and I, and again here 0, 4, 4, 0, I1, I2. I don't know whether it is visible or not, don't worry. I mean, at the edge, maybe some part may be cropped. So what is that? dv by dt equal to, what is the matrix I am getting? Minus 4 plus 4 minus 2 plus 4 minus 4 minus 4 plus 4, right? The minus 2 this is minus 1, right? So minus 4 plus 4 minus 2 minus 4 and 0, 4, 4, 0. Perfect. So this is how, so question looks very complex, but if you write, it is nothing but writing KCL and KVL and converting into matrix format. Matrix format. Yes, Sriram, thank you. Okay. So let's move for the next question. So the next concept we should discuss is a source transformation. So in the equivalent circuits, the next part of our discussion is a source transformation. Source transformation is basically a simplification technique used to simplify the network. To convert, sometimes source transformation sometimes can help you to convert a complex network into a simplified network. Uh, what is the how can we convert a complex network into a simplified network is by converting practical voltage source into its equivalent practical current source, and vice versa. A practical current source can also be replaced with its equivalent practical voltage source. So we can apply source transformation for the practical sources. We cannot apply for ideal sources. We can apply for dependent sources also, provided that dependent variable is not getting disturbed. Without disturbing the dependent variable, we can apply it. Okay. So this is the last topic or concept in the basics. Then we will move for the next chapter, network theorems. Okay. So here I will give you one shortcut. Then we can end this chapter. For example, just a moment, I am changing the values. Yes. So this is my question. I want to find V1 and V2. So इस क्वेश्चन पे मैंने V1 V2 निकालना पड़ेगा. एक मेथड डायरेक्ट नोड एनालिसिस से कर सकते हैं. दूसरा मेथड ये होता है by using source transformation. By using source transformation, this current volt source parallel with a resistance can be replaced with a voltage source series with a resistance like this. 10 in series with a voltage source of 8 into 10 is how much? 80. Here, whenever you have voltage source series with a resistance parallel with another resistor, you can apply here current source parallel with a resistance. Two resistors parallel equal to one resistor. Current source parallel with a resistor will give you voltage source series with a resistance, but it will take a lot of time. One shortcut here is whenever you see this kind of network, simplified network will be 16 into 12 upon 12 plus 6. Series with 12 parallel with 6, which is equal to 4 here, 12 here. Sorry, how much it is? I think 8. No, 18 and 18, 16. 16 into 12 upon 12 plus 6. Can you calculate this one? 18. Sorry, just change this value. Just for calculation convenience, I am replacing the value. So 12 into 12 by 12 plus 6. It will give you 8 volts. Right. Now, okay, what is the current? 80 minus 8 by 10 plus 4 plus I think this should be. I'm just changing the values, don't worry, because calculation will become easier. So 10 plus 2 plus 4. Okay. 80 minus 8 by 10 plus 2 plus 4. That will give you 72 by 16, 4.5. So 4.5 into 10 is 45. This will be 9. This will be 4.5 into 4. 18. Now what is this voltage? V1 equal to minus 45 plus 80 is 35. What is V2? 18 plus 8, 26. That is how we can find V1, V2 without node analysis by using your what we call source transformation. Here, generally we should not, suppose examiner asks you this current. Can we find this current in this circuit? Generally, once you apply source transformation, the branch which is disturbed, you cannot find the current in that branch. But we can find the response of I from this figure also. How can I find it, sir? Please listen carefully. If you compare both the circuits, there is an undisturbed branch. What is that undisturbed branch? This one. So here, what is the current? If this is 8, this is 8 minus I. So take this current as 8 minus I. So what is 8 minus I? 4.5. What is your I? 3 point. So this is a very important point. Please listen carefully. Suppose if examiner asks you to find this current, examiner को a current चाहिए. So जब मैं source transformation apply करेगा, once I apply the source transformation, I will be losing this information. Once I apply the source transformation, what's happening? I will be losing this branch. I cannot find I directly. So what I will do is, in both the networks, take the undisturbed branch. This is my undisturbed branch. So here the current in the first case is 8 minus I. Now you find this current, which is 4.5, equate to 8 minus I, then you will get the I directly, because this branch is removed after source transformation. So if you want this current, generally what is the people will suggest is, whenever you want current in any branch, don't disturb it. But after disturbing also, if you want to find this response, by using the relations, we will be able to obtain it. Okay, let's move for the next. So that finishes your first chapter of our discussion. First chapter of the discussion, the network, what we call basics. We have discussed KCL, we have discussed KVL, node analysis, mesh analysis, star delta. voltage division, current division, source transformation, and some equivalent circuits we have discussed in this particular topic. Okay. Now we are moving for the next chapter, network theorems. So why we should learn network theorems? Just give me one moment. Why should we learn network theorems? So generally we apply the basics KCL, KVL, node mesh analysis just to find in any network response obtain करने के लिए we can apply the basics. We can apply the basics in any network to find the response. Then where do we apply these network theorems? What is the implication, or where I can find, how can I identify, how can I use the network theorems? Means whenever you have a complex network, with several nodes, meshes, independent sources acting simultaneously. And if you are interested in finding response, you have a complex network with several nodes, meshes, independent sources acting simultaneously, but you are interested in finding the response in one branch. Say I have a complex network, but I only want to know how much current is flowing in this particular branch. I don't mind about the remaining network. Then I can replace the remaining network with its Thevenin's equivalent easily. If I want the response to be obtained in one branch such that how much resistance I should keep in this network, such that in this branch, if I keep this much resistance, I'll get maximum power. Then I can use maximum power transfer. If you have multiple sources, but you are concentrating on only one branch, then we can use superposition for finding response in one branch due to one source at a time. So all these comes under network theorems. If you have a complex network with several nodes, meshes, independent sources acting simultaneously, if we are interested in only one branch, then we take the help of network theorems. AC steady state analysis, resonance, everything I will discuss tomorrow. Transients also I will discuss tomorrow. All important topics will be coming in the tomorrow's session. Okay, shall we proceed? So you understand why or where we will be applying the network theorems, right? Chalo. Now, the first theorem of our discussion is superposition theorem. So superposition theorem is applicable in any linear network. So not only this theorem, all theorems are applicable only for linear networks. What is the meaning of linear network? Network made of linear elements. What are the linear elements? Resistor, inductor, capacitor, linear control sources comes under linear sources, linear elements of the network. If your network is made of resistors, inductor, capacitor, not diode, okay, then it is considered as a linear network. In a linear network, passive, bilateral network, we can say, or simply we can say linear. It can be passive or active, doesn't matter. Superposition is applicable. There are two principles must be obeyed for any linear network. They are homogeneity and superposition. So superposition is simply this one. If you have a linear network with multiple sources acting simultaneously, if you want response in one branch, we can obtain it by adding the responses due to each source individually. That is, the total response is equal to algebraic sum of individual responses evaluated by only one source at a time. If you have a multiple sources, you can find the response in one in a particular branch by taking only one source at a time. While taking only one source, remaining sources, if it is they are voltage sources, we replace with short. Current sources, we replace it with open. That's it. Dependent sources should not be disturbed. Uh, Not only this theorem, all theorems except reciprocity are applicable only for linear. They can be active or they can be passive, doesn't matter. They are applicable for linear networks. Okay. So the next one is homogeneity principle. It is applicable, obeyed by all linear network. What homogeneity principle is saying is, if excitation is multiplied by a constant in a linear network, the response in all branches are also multiplied by the same constant. For example, see here. Here I have a simple network, right? I have a simple network with some excitation, 12 volts. I have a simple network with some excitation, 12 volts. Now, 6 parallel with 6 is 3, 3 plus 3, 6. So what is the current I will get here? 12 upon 6, which is 2 ampere, and current divides here into 1 and 1. Now, what I am doing is I'm just changing this network with small change. I'm applying a small change to this network. Same network only. Input is say 36. Now what happens? 6 parallel with 6 is 3, 3 plus 3, 6. So what is the current I'll get? 36 upon 6, 6 ampere. Current divides to 3 and 3. Now what I want to say here is my input is originally 12. I made it 12 into 3. Excitation is multiplied by 3. Response earlier is 1 ampere. Now it is multiplied by 3. Earlier it is 1 ampere multiplied by 3. Earlier this is 2 ampere. It is multiplied by 3. Input is multiplied by 3. Response in all branches are also multiplied by the same constant 3. This is what we call reciprocity theorem. This is what we call, this is what we call homogeneity principle. Excitation multiplied by a constant k. Response in all branches are also multiplied by the same constant k. Multiplied by the same constant k. Okay. Chalo. These are the two principles obeyed by the what we call any linear network. So now I have two branches, right? I want to find the current in the resistor R is 0. What is the value of the current source I? Whenever two sources are acting simultaneously, we should apply superposition theorem. So by using superposition theorem, can you find the value of I? By using superposition theorem, try to find the value of I. Try to find the value of I. Please obtain the value of I. Okay, chalo, I will do it. I'll show you two methods here. Interestingly, we can apply by source transformation. We can also solve by superposition. First, I will solve you by superposition. Then without superposition, also we can solve it. Generally, in exam point of view, we don't apply superposition because it will take a lot of time. There are some questions where we may need to find individual response or where we cannot find the response without superposition. Then only we will use the superposition. Otherwise, unnecessarily you need to find the response with two sources two times and add them. It will take a lot of time. So let us do this question by two methods. So first is, let me take superposition, one source at a time. This is a 2. This is also 2. Okay. R equal to 2. I need to find what we call firstly, let me assume this current as IR1. Next time we will find IR2. Okay, so replace current source with a open circuit. Superposition theorem. I have a voltage source series with a resistance, parallel with a resistance. What is the equivalent? 2 parallel, 16 series with 2, parallel with 2. What is the answer? 1 and 8. This is a shortcut. V into R2 by R1 plus R2 series with R1 R2 by R1 plus R2 is the shortcut to find it. It's equivalent. Okay. Then this is 2 R equal to 2. So can you tell me what is IR1? It is 8 by 5. IR1 is 8 by 5. Second case. Let me apply the current source now and replace voltage source with a short circuit. Okay. So this will be, I'm writing here, 2 parallel with 2 is 1 and this is my R. Say this is my IR2 and current source parallel with resistance. What is the equivalent? Current source parallel with resistance. I into 2 will give you 2I. So आपका IR2 क्या होता है? What is your IR2? Opposite polarity. So minus 2I by 2 plus 1 plus 2 is 5. So examiner has given my IR is equal to IR by superposition IR1 plus IR2 is equal to 0. So 8 by 5 minus 2 minus 2I by 5 equal to 0. So 8 equal to 2I, I will be equal to 4I. So from the given information, I'll get I equal to 4, but it will take a lot of time to do by this process. Here also I applied many shortcuts, still it took a lot of time. So quickly I am revising, you just remove this source, find IR1, then remove the voltage source with a short, find IR2. Total response equal to sum of individual, but examiner has given IR equal to 0. From that I obtained I. Instead of doing this much, simply 1-2 steps you will get the answer. I will show you. Listen, examiner has given that this current is 0. If this current 0, what is this current? I. What about this current? I. Then what about this current? I. Drop will be I into 2. How much? 2I. If this current is 0, same current will be flowing in these two elements. So I can say these two elements are connected in series. So when the elements are in series, the resistance are equal, voltage divides equally to 8 and 8. Voltage division principle. When this current is 0, same current is flowing in these two elements, they are connected in series. When they are in series, we can apply voltage division principle. So this will be 8 and this will also be 8. So here let me take this as V1, V2 and I will take this as my ground just for understanding purpose. So what is V1 with respect to ground? 8. What is V2 with respect to ground? 2I. Whenever current through any element is 0, potential difference must be 0. Or you can say when this current is 0, this voltage must be equal to this voltage. V1 must be equal to V2. My 8 must be equal to 2I. My I must be equal to 4 amperes. Okay. So instead of doing that much, if your concepts are clear, you can do it within just less amount of time, the same question. Sir, here, is there any rule I should take ground here? No rule. You can also take ground. Same question I am solving by different method. I will take ground here. Then, what is V2 here? 0. What is V1 with respect to ground? 8 minus 2i. Because IR equal to 0, V1 equal to V2. 8 minus 2i equal to 0. 2i equal to 8. I equal to 4 amperes. I equal to 4 amperes. Okay, that's it. So any method will give you the same answer. If you have any query, you can ask me. Otherwise, I will move for the next topic. Okay, chalo. Now, this is one of the important concept in the superposition theorem. That is, superposition theorem is applicable for current response I equal to I1 plus or minus I2, voltage response V equal to V1 plus or minus V2, but you cannot apply superposition theorem for the power. P is never equal to P1 plus or minus P2. P1 is the power due to one source, P2 is the power due to second source, so total power is never equal to P1 plus or minus P2 because power is a non-linear relationship. Power is a non-linear relationship. So you can see here, read this question. Read this question. I have a network with multiple resistors. One resistor ka naam R. One resistor is designated as R. Then if two sources are acting simultaneously, power consumed by the resistor is P1 when first source is acting, and it is P2 when the second source is acting. When both the sources are acting simultaneously, what is the power consumed? When both the sources are acting simultaneously, what is the power consumed? So here, first source is acting, power is P1. I can say it is I1 square R, or I1 square equal to P1 upon R. I1 equal to root P1 by R. Similarly, when second source is acting, P2 equal to I2 square R, or my I2 equal to root P2 upon R. Got it? So what is my total current I1 plus or minus I2. So root P1 upon R plus or minus root P2 by R. So total power consumed will be I square into R. That will give you how much? Root P1 plus or minus root P2 whole square. Whole square. This one. So you can apply this plus or minus based on the current direction. Current direction. Now we will discuss Thevenins and Nortons. Okay. After short break of 10 minutes. ओके, सो मैंने टाइमर लगवा दिया, सो एग्जैक्टली 10 मिनट्स के बाद वी कैन कंटिन्यू विद द सेशन. ओके, विल बी बैक. आप भी छोटे से ब्रेक ले लो. वी विल बी बैक आफ्टर 10 मिनट्स. back. We can start. Okay, welcome back. Let's continue our discussion. So here we'll be discussing the next theorem, that is Thevenin's and Norton's. The next theorem of our discussion is Thevenin's and Norton's. So Thevenin's theorem and Norton's theorem, they are giving you the condition. Suppose you have a linear network. You have a linear network. If you are interested in one branch again, the remaining network in any linear network can be replaced by either its Thevenin's or Norton's equivalent, where Thevenin's equivalent is nothing but a voltage source VTH in series with a resistance RTH, or a Norton's equivalent of ISC parallel with a RTH, voltage source series with a RTH, voltage source series with a RTH. According to Thevenin's, any linear network can be replaced by its Thevenin's equivalent of voltage source VTH series with a RTH. इस पे VTH क्या होता है? VTH is the open circuit voltage measured across the terminals. RTH is the resistance measured by making all independent sources equal to 0. Similarly, Norton's is nothing but in any linear network can be replaced by, according to the Norton's, an ideal current source ISC parallel with a resistance RTH, where ISC is the short circuit current measured through the terminals. RTH is same as RN or RTH, both are same. But while finding RTH, keep this very important point in your mind. While finding RTH, we should replace all independent sources equal to 0. That is, while finding RTH, we are neglecting the resistance due to the independent sources. So RTH need not be equal to resistance of the network. Resistance of the network and RTH need not be same value. They can be different. Okay. Please understand this point. While finding the resistance, if the network contains independent source, it will offer some resistance that is not considered while finding the RTH. So RTH is valid when you have VTH in series with it. But if you don't know the input voltage of the network, if you don't know the independent source values, then only RTH can be obtained in that particular case. Then even the examiner asks you to find the resistance also, we find only RTH. For example, I will show you this. In this case, be careful here. So examiner question here is to find input resistance. What is the input resistance here? Input resistance here will be, this is 10, this is 10. Okay, 10 by 5, 2, 10 by 10, 1, 1 plus 2 plus 1, 4. Input resistance here will be 10 by 4. How much? 2.5. Means this remaining network can be replaced with 2.5. Then this will be 10. How much current I'll get? 10 upon 2.5. 4 ampere. So this and this are same. Now, suppose this question, if you try to solve by using Thevenin's, what happens? So if I try to solve this question by Thevenin's, this will be 10 and this will be 5. Old current source should be replaced by open circuit. RTH equal to 10 parallel with 5. 10 by 3. Okay. So 10 by 3 if you connect across 10 volts, it is of no meaning because the current will be 10 upon 10 by 3 will give you 3 amperes, which is wrong circuit. So if you replace this with 2.5, I am getting same current in both the networks. But if I replace with RTH, I am not getting the same current. Then what to do here? What to do here? Listen carefully. Find VTH also. Find VTH also. You will get here 2 by 3, 1 by 3, 10 by 3. So what is VTH here? VTH equal to minus 10 by 3. And RTH is 10 by 3. Suppose if you connect now VTH and RTH together across the 10 volts. VTH and RTH together across the 10 volts. Many people will don't tell this. So you may assume RTH and R are same. RTH different, R is different. That is why I am explaining this concept. Now what is your I? 10 minus of minus plus 10 by 3 by 10 by 3. So it will give you 40 upon 10, 4 amperes, same as your original circuit. So I can say here my RTH is valid only when VTH is already given or RTH is also present. So it will both of them together represent your network. Only RTH does not represent your network. So now in the networks, there are three kind of networks they can ask you for Thevenins and Nortons. One is only independent sources. If you have only independent sources, then you can find VTH, you can find ISC, RTH directly. But if your network is given with both independent and also dependent, then you find VTH and ISC directly. How do you find RTH is when you are finding RTH, you should not disturb the dependent source. By applying some input voltage and assuming some current is flowing, voltage current ratio will give you RTH. Otherwise, we can also find RTH equal to VTH by ISC. Another model they can ask you is network with only dependent sources but no independent sources. There VTH and ISC will be 0, only RTH will be calculated. So three model of questions can appear in Thevenin's and Norton's. We'll see 1-2 examples also, then you'll get more clarity on this. So we'll be discussing that. Okay, let's move. Firstly, I will write the models for your understanding. Okay, model 1 is VTH network with only independent sources but no dependent sources. Here VTH, ISC and also RTH can be obtained directly. The next one is network with both दोनों high square, both independent and dependent. Here VTH, ISC can be obtained. RTH is equal to VTH by ISC. This is the relation between Thevenin's and Norton's. VTH and RTH and ISC. So last model they can ask you is Okay, here network with only dependent but no independent source. Here VTH equal to ISC, both are equal to 0. Only RTH will be obtained, which is non-zero. So one of the important model here is a bridge model. Examiner can ask you this kind of questions more frequently. Find the current I. So here you observe, I want to find the current in the 5 ohm resistor. What I will do is I want to replace the remaining part of the network with its Thevenin's equivalent and find the response by replacing the network with its Thevenin's equivalent. Let us see how can I do that. Is it a bridge balanced 10 by 6? Not equal to 15 by 8. So find here Thevenin's VTH, RTH between A and B. A और B का बीच में Thevenin's निकाल दो. Then you can connect 5 ohm resistor. Find the current I. So VTH upon RTH plus 5. Got it? So हमने यहीं पे केवल VTH और RTH निकालना. Just we need to find the VTH and RTH. Let us see. Okay. Now, can you tell me what is VTH here? VTH is equal to 100 into 6 by 6 plus 10. I can find this voltage VA minus VB. I can also find it from the top. This voltage minus this voltage. It is just like loop equation KVL. Minus 100 into, because they are in series, I can apply voltage division principle. 8 upon 15 plus 8. So that will give you 2.71. For finding RTH, what to do here? Replace voltage source with a short circuit. Okay. Now I have A, B. Okay. So you can see here. So what is your RTH? 10 parallel with 6, 15 parallel with 8. You get 8.96. So in this network, what is the current here is? Current will be how much? 8, oh, sorry, 2.71 VTH upon RTH plus RL. That is 2, 1. So I want to give you one point here. Just remember, this kind of network mein VTH is directly given as, suppose you take here R1, R2, R3, R4 and V. Remember, because it will be most frequently occurring kind of question. So V into R2 upon R1 plus R2 minus V into R4 upon R3 plus R. And your RTH will be, replace voltage source with a short circuit, 10 parallel with 6, right? R1 parallel with R2 plus R3 parallel with R2. This you can remember as a permanent formula. Whenever you find unbalanced bridge, you can directly find the Thevenins using these equations. Chalo. This is one of the important model, and other than that, model 2 contains both Thevenins and what we call both independent and dependent. Model 3 also most frequently occurring, that is only dependent sources are given. We don't have independent. How do you find here? VTH is equal to 0, ISC equal to 0. But how do you find RTH is? I am not doing this, but you can give a try. Find, assume V and I, the ratio RTH will be equal to V by. But while finding RTH, never find RTH without connecting this. Because if you don't connect it, if you after connecting, you will understand this IA will be different and this current will be different. But if you don't connect it, you may assume the IB current is flowing here also. So always for finding the resistance offered between the terminals, connect some source, then only calculate it. Otherwise, you will get a wrong answer. So can you find RTH here? Because no independent source is present, VTH and ISC are 0 directly, I can say. Can you find RTH? Can you calculate RTH here? How can I find RTH? Here, RTH can be obtained by, assume some voltage source V here, say Vx and Ix. Why Vx and Ix? Because already I have I here. So to avoid confusion, I am taking Vx and Ix. Let me take this node voltage as Vx. What is this drop? 4i. So I can say my Vx equal to 4i. Let me apply node analysis here. So Vx minus 4i upon 2, Vx by 2 plus Vx by 4 minus Ix equal to 0. Okay. So but 4i and Vx are same, 0. Vx by 2 plus Vx by 4 equal to Ix. So Vx by Ix equal to 1 by 2 plus 1 by 4. Okay, right? So, I mean, because Ix by Vx is 1 by 2 plus 1 by 4. Vx by x is its inverse, that's it. So here, is there any shortcut I can do this question easily? Is I will show you. Without doing this much, I can throw a shortcut for you, which is very easy instead of doing this much stuff. You can see here, if this parallel voltage is same, right? This is also 4i only. If this is 4i, this is 4i. What is this current? 0. If the current is 0, what is this current? 0. So what is the resistance offered by the dependent source is given by its voltage current ratio. Voltage is 4i, current is 0, it is infinity. Okay. So I can say this is replaced by, you can be replacing it by open circuit. Then what is RTH? Directly I can say 4 parallel with 2, which will give you 4 by 3. What I have done is, because this is 4i and this is 4i, no potential difference, no current will be flowing. Because this current is 0, this current is also 0. Voltage by current ratio will give you infinity. I can replace the dependent source with an open circuit in this case, and RTH is equal to resistance offered by the dependent source is infinite. So open circuit it, then 4 parallel with 2 directly, 4 by 3 will be your answer. Like that we can calculate. So the next theorem we can discuss is very important. Thevenin's Norton superposition, and mostly maximum power transfer theorem. They are asking the question every single year. Every single year, one question. I mean, coming from at least any one of these topics, one question definitely appears. So let us discuss this maximum power transfer theorem. Last 1 hour of our total discussion, and in this 1 hour we will complete these theorems and hopefully two-port networks also. Tomorrow we will discuss only transients and AC analysis. Both are very important topics. Okay. So maximum power transfer theorem. So here, what is this theorem? What this theorem will do? This will give you the condition for maximum power transfer from source to load. When load is a variable quantity only, we can apply this theorem. If load is not a variable quantity, never apply this theorem. We cannot apply this theorem when load is not a variable quantity. Very important point. When load is not a variable quantity, choose minimum internal resistance, which will give you maximum power. Here, two possibilities are there. If you have a DC case, that is your excitation is DC. In that case, what is the condition for maximum power transfer? For maximum power transfer, suppose you have like this Vs in series with a Rs, and we have connected a variable load RL. Okay, for maximum power transfer, what is the required condition? RL must be equal to Rs. Similarly, for AC condition, okay, you have, sorry, Vs Zs equal to Rs plus Jxs. Okay. In this case, what happens is here, this is your load. In that RL can be variable, XL can be variable, both can be variable, XL can be zero also, all cases possible. First case, here I will write a table which is very important. Variable and maximum power transfer condition. If RL is variable, what is the required condition for maximum power transfer is RL must be equal to RS square plus XS plus XL whole square. In this, if XL equal to 0, मेरा RL कितना होना पड़ेगा? My RL must be equal to root of R square plus XS square, which is mod ZS, I can say. Now, if XL is variable, then what is the required condition for maximum power transfer? XL plus XS must be equal to 0. When both are variables, then RL must be equal to RS and XS plus XL must be equal to 0. Load must be complex conjugate of the source. Okay. So in here the power consumption is given by the formula V square into load resistance by RS plus RL whole square XS plus XL whole square. Here when what is the maximum power you will get is V square by 4RS. And efficiency of this theorem is 50%. 50% of generated power will be wasted in internal resistance under maximum power transfer condition. So when RL is getting variable, when RL is equal to RS, you will get P will be equal to P maximum. Okay. P equal to P max. So this is the condition. These are what we call maximum power transfer theorem conditions for DC excitation and also AC excitation. So let's move further to understand the next part. So this is one of the, this is one question appeared in one of the exam. We need to find the maximum power transfer condition. Here we can find the power consumed by the current source maximum when it will be maximum. That is the question. So I can make dp by di equal to 0. That is one method. Otherwise, I can also make like this. What I told here, for maximum power transfer, my RL must be equal to RS, right? So my RL must be equal to RS. What is RL here? V by I. What is V? If you take I here, I into Rs, because all are in series. V equal to V equal to Vs minus Irs. Vs minus Irs. Okay, by I. So this is the required condition. RL must be equal to Rs. So this must be equal to Rs. So Vs equal to Vs minus Irs equal to Irs. Vs equal to 2 times Irs, or I equal to Vs by 2Rs. So this is the required condition for maximum power transfer. I must be equal to Vs by 2Rs. Or you can also do like this. For maximum power transfer, n number of ways we can solve it. RL equal to Rs, right? Then I is equal to V by total resistance RL plus Rs. If RL equal to Rs, I can say that's it. Okay. We can also take VRL equal to VRS because RL equal to RS. From that also we can solve it. Any method. So what is the condition? Current should be equal to Vs by 2Rs. Now I'll ask you one question based on this. It is given in one of the ESC examination, not in GATE, but you can apply this for GATE also. So here I want to find this current source value for maximum power transfer. How can I find it? So I may give you 1 minute, you can give a try. If you are not able to do it, I will help you to answer this. Come on, please try. Please try. Find the value of current I. Find the value of current source I. Okay. Okay, I will do it. Just a moment. Okay. So no answer, no issue. I'll do it. So here also, firstly, I told the Thevenins can be applicable only when the network should be in a form of like this. Between A and B. Now connect some current source. I. Okay. So what is the required condition here? If you assume this as VTH, RTH, what is the required condition? I must be equal to, from the previous example, VTH by 2 RTH, right? V by 2I, previous question, right? Vs by 2 RS. Now, how can I convert this into this? By using Thevenins. Previously, we have solved one question. What is the Thevenin's equivalent of this is 24 into 6 by 6 plus 3 minus 24 into 4 upon 4 plus 4. That will give you 16 minus 12, 4. What is RTH? If you replace voltage source with a short circuit, current source you remove it, then 6 parallel with 3 plus 4 parallel with 4. That will give me 2 plus 2, 4. Okay. So my current will be 4 by 2 into 4 is how much? 8 point. So that is the value of the current source to be connected between A and B. And direction should be A to B because it should be absorbing, not delivering, right? So for maximum power transfer. So this here, same story, but dependent source is given. You need to find the value of RL for maximum power transfer. Same way we can do it by finding this RL by using Thevenin's. Find RTH of this network, that will solve your problem. How can I find the RTH here? Replace voltage source. I am doing by shortcut approach because I can teach you something new. Okay. So see here carefully. I want to always connect here some source, then only find RTH. So what is the RTH? V by. So what is the maximum power transfer condition? For maximum power transfer, RL must be equal to RTH. Okay. So here, if these two resistors are in series, if this is Vx, this is also Vx only. Because they are equal resistances, current is same when they are in series, so voltage must be same. That is fine. Next here, if it is Vx, 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 by loop equation, this must be equal to 3Vx. This must be equal to 3Vx because this voltage should be equal to sum of these three voltages. So what is the current you will get here? 3Vx by 4. How I get 3Vx? Because sum of these three voltages. So what is this one? 3Vx by 4. Current direction is negative to positive. So what is the resistance of the dependent source here? Negative 3Vx by 4 by Vx. That will give you minus 3 by 4. Sorry, just a minute. Voltage by current, right? Voltage Vx by 3Vx by 4. So minus 4 by 3. So my RTH will be equal to 4 plus 4 parallel with 4 minus 4 by 3. So 8 parallel with 12 minus this is 8 by 3. So it will give you 8 by 4, 2 as the answer. So what is the value of RTH here is 2. This is how we can find RTH easily. Whenever you know current in the dependent source, you can replace it with a resistor of its voltage current ratio. But arrow direction is negative to positive minus, positive to negative plus. You should take. Chalo. This is also a wonderful question. I have a DC power supply acts as an ideal 4 ampere current source as long as its terminal voltage is below 10, and beyond that it behaves like a voltage source for all loads. Current becomes up to 0. When the ideal rheostat is connected, find the load resistance at which maximum power is transferred and corresponding the load voltage and current. So the beauty of this question is understanding. If you are able to understand the meaning, sometimes questions will be given like that, which are looks like they are not possible, but you should only take the statement into consideration. Whatever given in the statement, based on that, you should be able to answer it. So please give a try. Based on the statement given by the examiner, give a try and try to answer it. Just 1 minute I can give you the time. You just try and understand at least read the question. That is enough. Then I can help you. Just here the best part of the question is understanding. If while writing exam also, if you are able to understand the question, 50% of your problem is already solved. So please give a try, guys. Please give a try. Come on. Please try. Just 1 minute. If you are able to do it, it's fine. Otherwise, I will explain it. Okay, I will do it. Okay, I will answer it. Listen. Firstly, try to understand the meaning of the question. What he want to say. In this question, I have a DC power supply acts as an ideal 4 ampere current source as long as its terminal voltage is below 10. Okay. So I have a 4 ampere current source. We have connected some rheostat, that is the resistance. Okay. What is your voltage V? 4 into R, because current source is an ideal current source as long as this is less than or equal to 10. That is R less than or equal to 2.5. So here variable resistance R is 1, 2, 2.5, that it will work like a current source. After that, for R greater than or equal to 2.5, it is working like a voltage source of 10 volt. So after that, it will be staying constant as a 10 volts. For resistances increase, now what is the current I? 10 by R. When R increases, current decreases. Current going down to 0 also, he said, means when you increase the resistance up to infinity also, it will stay as a ideal voltage source only. So now first case, what is the power is equal to 4 square into. Second case, what is the power? 10 square by R, because here current is constant, I square into R I have taken, here voltage is constant, V square by R. So here in this case, when R is maximum, I will get power is equal to maximum. So R should be less than or equal to 2.5. So what is the required condition? R equal to 2.5. You will get power will be maximum. But in this case, if R increases, power decreases. So what is the condition here is R minimum, power will be maximum. Power will be maximum. So here R greater than or equal to 2.5. What is the minimum value of R is 2.5. So both of them are saying that when R equal to 2.5, you will get the maximum power. So R equal to 2.5, you will get voltage is equal to 10, current is equal to 4. Okay. So this is the condition for maximum power transfer. Okay. What is the condition for maximum power transfer? R must 2.5 ohms and this is 10. 2.5 ohms, 4 ampere and 10 volts. Got it? Chalo, let's move for the next. So I hope you can answer this question very easily from the discussion we have done. Come on, you can answer it very easily here. Here R is variable or not variable? When R is not a variable quantity, choose, see here, sorry, not R. When load is not a variable quantity, load is fixed. R must be as minimum as possible. Ideally, R should be equal to 0. 0 is not given in the options, take the this one. Suppose examiner asks you maximum power here, then you can apply what we call maximum power transfer by finding across this Thevenin's equivalent. In that case, you get 2 is the required answer. 4 parallel, 6 parallel with 3. So you understand here you want maximum power transfer in the 3 ohm resistor, which is a fixed quantity. So we cannot apply the theorem. So this is another important model that can appear in your maximum power transfer is some complex network will be given. They will ask you what is the condition for maximum power transfer from network A to network B. So generally if it is 2, don't assume R should be 2. This total network should be equal to 2 is the required condition. For maximum power transfer, total network B must be equal to complex conjugate of the source, not R. Okay. So then what is the current you will get here? 2.5. So what is the required condition for maximum power transfer is this current should be 2.5. What is that current? I must be equal to I must be equal to 10 minus 3 by 2 plus R. 7 upon 2 plus R equal to 2.5. So that will give you 2 plus R, 7 equal to 5 plus 2.5 R. 2.5 R is 2. R equal to 2 upon 2.5. 0.8. Okay. Next. The next theorem of our discussion is reciprocity theorem. We have few theorems: reciprocity theorem, duality principle, Millimann's theorem, compensation. All these are the next theorems we have. And the first one we are discussing is reciprocity theorem. So reciprocity theorem will give you the condition that in a linear, up to now the theorems are applicable for linear networks only. Up to now whatever we discussed, all these theorems are applicable for linear networks, but this particular theorem is applicable for linear, passive, bilateral. So the network must be bilateral here. The network must be bilateral here. So reciprocity theorem is giving you the condition when the network is linear, passive, bilateral, then the ratio of response to excitation always remains constant. That is, output to input ratio will remain always constant even though you interchange your input and output terminals, even though your source, excitation and response are interchanged. Let me show you with example. But firstly, see here, these are the rules. In a linear passive bilateral network, the ratio of response to excitation always remains constant even though we what we call the input and output terminals are interchanged. This theorem is applicable for linear, passive, bilateral networks. Network with resistor, inductor, capacitor as elements, not dependent source. It is not applicable for active. But specifically, we can design the networks such that it will satisfy the reciprocity. But by default, it is not active network, so it will not satisfy the reciprocity theorem. So let me show you with some example here. Just for understanding purpose, here I take some random network. 6 parallel with 6 is how much? 3. 3 plus 3 is 6. So what is the current you will get here? 24 upon 6. 4 amperes. Now the 4 divides to 2 and 2. So here what happens? Same network, what I am doing is I will apply in the reverse. How much current I will get in this branch? So 3 parallel with 6 is 2, 2 plus 6 is 8. So I will get here 24 upon 8, 3 amperes. Okay. So this 3 will be dividing here into, I want this current, right? So my current I will be equal to total current into opposite resistance by total resistance. So 24 into 24 9, total current is 3. Total current into opposite resistance upon total resistance. That will give you 2. So what is the final conclusion? If you apply 24 here, you are getting 2 here. If you apply 24 at the other end also, you are getting. Remaining branch currents need not be same. That is, they are same for homogeneity, but not here. So excitation is and ratio of response to excitation remains constant even though you interchange the input and output terminals. But when you replace voltage source here, you should replace it with a short. Similarly, you can apply this rule for current sources also. That many people don't discuss. Current source is kept, what happens? I will show you. Okay. Now what happens here? 3 plus 3, 6, 6, 6. How much current divides equally to 3 and 3? What is the drop you get? 9. So here 9 parallel with 3, current division principle, this will be 6. Okay. This is 9 and 3 means 3 times and 1 time. Current divides into, you get 4.5 here, 1.5 here. The drop will be 1.5 into 6 will give you 9. So, but you should be careful while replacing current source should be replaced by open circuit. Now also the ratio will remain same. Understand? So that is what we call reciprocity theorem. One of the important model in the reciprocity theorem is, for example, have a network. Its VTH is equal to say 6, just for understanding. Okay, linear network. Linear passive bilateral network. Now, if my input is made, that is the same linear passive bilateral network, if I made my input is equal to 10 is made equal to 20, then what is VTH? 6 earlier, now 20 if I make, then it will be 12. So, for a linear and reciprocal network, VTH can be given by K times Vn. Input doubles, VTH doubles. But there is another exception called linear and non-reciprocal network. Then VTH will be K1 into Vn plus K2. Some constant will appear. Why, sir? Suppose here we have only resistor. Current is present. V equal to IR. When input is K times, here also K times. Okay, it is a passive network. But if you have like this resistor and also some constant K2, then what happens? Here you get IR plus K2. If input is doubled, this part will double. This part may remain constant. So that K2 may be 0 also, but non-reciprocal network, some extra constant to be considered. Extra constant is to be considered K2 for a linear and non-reciprocal. Input is doubled, VTH need not be doubled. Okay. So now you see here with this kind of question is appeared in one of the exam in GATE 2012. You can just read the question. I will be helping you. I will be answering you this question. Okay, just read it. I will explain. So see here, I have a 10 volts DC at port A, linear, non-reciprocal, very clearly specified. Any linear network we can apply Thevenin's, but non-reciprocal. 1 ohm connected at the port B draws a current of 3 amperes. 2.5 ohm connected at the port B draws a current of 2 amperes. Let's use this information. Okay, let's use this piece of information. I have VTH. I don't know RTH. I'm writing very small. Don't worry. Now, what is the examiner given condition? Some R. What is the current I? VTH upon RTH plus R. Now, first case, VTH upon RTH plus, okay, what is that? 1 equal to 3. So, VTH is equal to 3 times RTH plus 3. Second condition, VTH upon RTH plus, what is the resistance given? 2.5, it is equal to 2. So, VTH equal to 2 RTH plus 5. Okay. Now, solve 1 and 2. You will get VTH equal to 9, RTH equal to 2. 2 2 is 4, 4 plus 5, 9, 3 2 6, 6 plus 2, 9. Anyway, what is the conclusion is when first case input is equal to how much? 10 volts he has given. When input is 10, I am getting my VTH is equal to 9, RTH is equal to 2. That's it. Next, third possibility is for the same network, when input is equal to 6. Okay. And see here, when input changes, VTH will change, RTH will never change, because RTH definition itself, the resistance measured by making independent source equal to 0. So RTH never depends on the VTH. So Vin is changed. Now I will get some VTH, but RTH is already obtained. How much RTH will get? 2. Now what is the question of examiner? 1 ohm connected at the port B. If I connect 1 ohm, what is the current I will be getting? It 7 by 3. So VTH upon 2 plus 1 will be 7 by 3. My VTH will be 7. So what is the conclusion here? When Vin is 6, I am getting 7. Vin is 10, I am getting VTH equal to 9. Now what is the question of the examiner? If 8 volts is connected at the port A, what is the open circuit voltage at the port B? So if I connect 8 volts at the port A, what is the output voltage I will be getting? Open circuit voltage. Open circuit voltage is nothing but Thevenin's voltage. Thevenin's voltage, how to find it? Let us see here. Uh, Firstly, when Vin is equal to 10, what is the formula for VTH? Is K1 into Vin plus K2 is given by 9. Second possibility, when Vin is equal to 7, so 7, 9, 6, huh? VTH is equal to K1 into 6 plus K2. Okay. So if you solve 1 and 2, I will get my VTH equal to, I will get, see, two equations, two unknowns, right? K1 equal to 1 by 2 and K2 equal to 4. So my VTH equal to 1 by 2 into Vn plus 4. You substitute here, suppose 10, 10 by 2, 5 plus 4, 9, 6 by 2, 3 plus 4, 7. So now what is the question here? Vn is equal to 8. If I apply 8, what is the Thevenin's voltage? Half into 8 plus 4. 4 plus 4 is 8. 4 plus 4 is 8. Okay. So what is the answer? 8 volts. Okay. So last 20 minutes of our discussion. Let me finish these theorems and to put also a small topic. So the next theorem of our discussion is Milliman's theorem. So according to Milliman's theorem, if you have n number of Thevenin's equivalents or practical sources connected in parallel, you can replace them with a single source. I'm not proving this. We can prove it by using source transformation. It is a very simple theorem, because if you apply source transformation to the sources, you get n number of current sources in parallel. You can add them and again apply source transformation. You can transform this into a single source. N number of sources connected in parallel can be replaced by a single source of R dash in series with V dash. So V dash will be V1 G1, V2 G2 and so on Vn Gn by G1 plus G2 up to Gn, where R dash is 1 upon G1 plus G2 up to Gn, where Gn is conductance 1 by R. Okay. So this is how we can replace multiple sources with a single source using Milliman's theorem. Can you tell me what is the current I here? Very simple. What is your, first you can replace all of them with a simple source of V dash. Is 200 into 1 upon 50, 160 into 1 upon 40, minus 100 into 1 by 25, minus 80 into 1 upon 20 by 1 by 50, 1 by 40, 1 upon 25 plus 1 by 20. All of them will give you 0. So here your V dash is equal to 0. R dash I am not calculating because 0 hai to koi bhi ho sakte, current will be equal to 0. So like that multiple normal node analysis se bhi kar sakte. You can do it by node analysis also, which will take a little more time. So this is one approach you can apply Milliman's theorem. So can you answer this question based on what we discussed till now? Please give a try. Try to answer it. Okay. Here, this kind of problem we cannot apply Millman's theorem. Here you can apply only superposition because omegas are different. This is omega 1, this is omega 2 because inductor and capacitor will be having the reactances 1 upon j omega c and j omega L. When omegas are not same, we cannot apply the Millman's theorem here. Why? Because here the reactance will be different for 100, different for 200, same for inductor and capacitor. So when you have two different frequencies are acting simultaneously, if you have inductor capacitor in the network, compulsory we can apply only one theorem, that is superposition. One source at a time, find the response. Another source, find the response. We cannot apply any other theorem. There is one principle called duality. According to duality, in fact, this is applicable in any subject like network analysis. We have this duality principle. Digital circuits, we have the duality principle. Signals and systems also, time domain, frequency domain. In digital AND gate or gate, like that, everywhere we can apply this duality principle. So according to duality, कोई भी network ले लो, इसका डुअल से रिप्लेस कर सकते हैं. हम डायरेक्टली सॉल्यूशन निकालना चाहे तो कर सकते हैं, नहीं है तो इसका डुअल करके सॉल्यूशन निकाल के उसका एक और बार डुअल किया तो आपको ओरिजिनल सॉल्यूशन मिल पाएगा. So you can find the network solution directly, otherwise find the dual and dual of the dual will give you the original solution. Whenever you are not able to find directly, we can take the help of dual. So the basic dual pairs are resistance, conductance, inductance, capacitance, series, parallel, current, voltage, star, delta, Thevenin's, Norton, series, parallel, all comes under dual pairs. I'm not discussing much about this because exam point of view it's not अभी तक questions नहीं दिया इससे ज़्यादा questions, so no need to worry about that. So the next, all other theorems similarly. So here, try this question. Determine the dual of the series RLC network. Dual of the series will be parallel GCL network. Here L should be replaced with a C of 3 farad and C should be replaced with L of 2 Henry and R should be replaced with G of, don't take 1 by 10, take 10 only. You may get the doubt, sir, G equal to 1 by 10 lena. That is equivalent, but for a dual you should replace G with R value. G equal to 1 by 10 mat lena, G equal to 10 lena, G equal to 10 mos. Okay. For a dual you should replace R with G. So another important theorem is substitution theorem. Substitution theorem is giving you a very simple, we can say any passive element can be replaced with its equivalent active element of voltage source without disturbing voltage current relationship. For example, you have 10 ohm and 2. Okay, what is the, you can also replace this with a 20 volts source with a 2 ampere. So this is what we call substitution. So whenever you don't have one particular element, when it is feasible to replace the passive with the active, we can do it, but it should not deliver, it should be absorbing. But here resistor is resistance fixed, here it is not fixed. So this is valid for one input only. Reverse substitution is also possible. We can replace active element with a passive resistance. So finally, one more theorem is there, compensation theorem. So compensation theorem is giving you very simple condition. Suppose you have a network. There is a network with source and resistances. You are getting one particular current in a particular branch. But that resistance, assume one branch resistance is 6 ohms, current is 2 amperes. But that 6 ohm is getting disturbed to 5 ohms. Because of this disturbance, every current will disturb. Means even load is variable, or when you assume some resistance, but original resistance is not that much. Because of these conditions, network will suffer disturbance in every branch. So to overcome that, what we can do is we can use compensation theorem. So suppose if you have Z with current I. Suppose if you want to replace this Z, Z is varied or replaced with Z plus or minus delta Z. Then here you connect one source of reverse polarity I delta Z. Then what happens is the current will remain again same, because I delta Z and minus I delta Z will cancel and you will get the same thing again. This is what we call compensation theorem. When impedance is disturbed by some delta Z, connect a source with opposite polarity of earlier I into delta Z. Then the current in the network in the first case and after disturbance will remain same. In other branches also the current will remain the same. So this is the question given. You can see network of impedance Z is has increased from Z to Z plus delta Z. The solution of the network will remain same when an EMF of minus I delta Z is introduced in series. This is what we call compensation theorem. So that finishes your network theorems. Now we will quickly move to the two-port networks. We'll finish it off and we can end the session. Tomorrow, happily, we can discuss Thevenin's and AC analysis. Sorry, tomorrow we can discuss transients and AC analysis. Guys, if you have not yet subscribed to this channel, please subscribe it. You will get more content of EC and electrical engineering. Not only content, career guidance, many other initiatives will be available here. And you will be getting solid. This is just, we are in the beginning only. You will be getting a lot of initiatives in this channel. In the first few days itself, we are giving a lot of content for you. Just all I need is give a big like to this session or whatever the sessions you are interested, and subscribe to the channel compulsory. You will be getting the updates and all. So two-port network. What is the meaning of a port? Port is nothing but a pair of terminals. So V1, I1, V2, I2. Okay. So out of the V1, I1 and V2, I2, four variables, we take two variables as independent and two variables as dependent. So out of the four, to select two, 4C2 possibilities are there. You get six parameters. How many parameters are possible? Six two-port network parameters are possible. Z, Y, T, T dash, G and H. Z, Y, T, T dash, G and H. So these are the six different two-port network parameters available with us. And you can see here why we apply two-port network is just like a black box here. If network is not physically available, even you don't take the network physically, by doing some experiment, finding V1, I1, V2, I2 relations, we can frame the equation of the network. From the equation of the network, we can solve the network without original physical network. We can find its Thevenin's equivalent, we can find its input impedance, output impedance, voltage gain, current gain, everything. That is the advantage of two-port network analysis. So here, the basic two-port network analysis, firstly, we should classify the networks into reciprocal and non-reciprocal. If the network is reciprocal, it will be satisfying the reciprocity theorem. Network made of linear passive bilateral is a reciprocal network. Similarly, another network is symmetrical. If the network offers same impedance from both input and output, then it is called as a symmetrical network. So symmetrical network will offer you same impedance from both input and output ports. If you divide the network into two parts, right half and left half are same, then also we can say it is a symmetrical network. Okay. And uh, what we call it looks same from both the sides, then also symmetric, but those are sufficient, not necessary. Necessary is the impedance must be same from both the sides. So you have this one, 1 2 1. This one is a reciprocal network and also symmetrical network. Suppose you have 1 2 and 3. In this case, this is asymmetrical network. But any resistive network, any passive network is a linear passive network is a linear passive bilateral network is a reciprocal, but need not be symmetrical. So the basic parameters, if you take here out of the variables v1, v2, if you express in terms of i1, i2, then you will get z parameters. You can write it in the matrix form also. And here z12 equal to z21, that is v1 by i2 equal to v2 by i1. Transfer impedance we can say, because the voltage at one point, current at other point, it is a reciprocal. If z11, z22 equal, then it is a symmetrical. Its inverse will be y parameters. Similarly, these are ABCD parameters which relate to, these are the only parameters which relates complete input port with the complete output port, V1, I1 in terms of V2, I2. Similarly, generation side and receiver side, transmission line analysis, etc. we will use. Here why minus? Because I2 is entering current, minus I2 will represent the leaving current or the load current. So for a symmetrical network, determinant of this matrix is 1. For a reciprocal network, symmetrical network, A equal to D. Its inverse is T dash. Similarly, the H parameters, V1, I2 equal to, this is the equation, hybrid parameters, input voltage and output current here. That is, you remember in this way, because ABCD is input and output port, easily you can remember. Z and Y, you can remember VI or I by V ratio. For hybrid, V1, I2. Here H11 will represent input impedance when V2 is 0. H12 will represent voltage gain, reverse voltage gain when I1 0. H21 will represent current gain when V2 0, and H22 will represent output admittance when I1 is 0. So here reciprocal network H12 equal to minus H21. For symmetrical network, determinant will be equal to 1. Okay. So inverse of H is G. So what is the relation between Z and various parameters is Y equal to Z inverse, T dash is equal to T inverse, G is equal to H inverse. So these are the relations between various two-port network parameters. Now, can you answer this question based on what we discussed? Okay. So here right. Here he asked the two-port linear network open circuit output voltage, that is V2, to the input current I1. Open circuit means I2 equal to 0. V2 by I1 is Z21. Z21. Z21 is equal to, don't take 1 by Y1. Z21 is equal to Z12. Can you take Z21 is equal to 1 by Y21? No. Z matrix is equal to Y matrix. So, it is 1 by determinant of Y into Y22 minus Y12 minus Y21 by Y1. So, what is Z21 minus Y21 by mod Y? Don't take Y Z21 equal to 1 by Y21. Total matrix inverse. Don't take individually because Y21 is I2 by V1. Z21 is V2 by I1. Don't relate them. So generally there are two important networks. One is this one, T network. For T network, you should know the Z parameters. ZA, ZB, and ZC. For the T network, what are the Z parameters is given by? You should remember, it is very important. ZA plus ZC. Something wrong. ZC, ZC, ZB plus ZC. Similarly, for pi network, assume this is admittance. Okay. What are the Y parameters is? YA plus YC minus YC minus YC, YB plus YC. Okay, that is the Y parameters. Suppose this network is given. What are the Y parameters means? So don't blindly add the impedances. You should convert ohms into mhos. You should remember this formula. It is very much helpful in the problems. There is another network, half T section. This one also you should remember. For this, what are the T parameters you should remember? 1 plus ZA by ZB, ZA 1 by ZB. If you know Z parameters of one network by using what we call the relations, you can find the Z of any. So let's solve this question and we can leave. In the given network, Z parameters are given. Generally, the input impedance is given by Z11 minus Z12, Z21 by Z22 plus ZL. Similarly, if you want ZTH from this side, ulta formula Z22 minus Z21 into Z12 by Z11 plus Z of the source. So he asked what is the value of, suppose you replace the net here, network is not given, only parameters are given. From that you will be able to find the solution. Say this is VTH and ZTH. What is the value of ZL required for maximum power transfer? Assume it is a DC only, ZL must be equal to ZTH, or here originally RTH. So what is your RTH? If it is normally it should be complex conjugate, but ZTH is equal to RTH. So RL equal to RTH because it is DC. So what is Z22 here? 120 minus 60 into 60 by 40 is the Z11 plus what is the input impedance they have converted. So 36 120 minus 72 48. So that is how you can find the VTH also. I mean ZTH from right. Sometimes they give you this like this. They ask you VTH. How do you find this? Just model the network. What is ZTH formula? V1, V2 equal to Z11 I1 plus Z12 I2. So Z21 I1 plus Z22 I2. So just make a network which satisfy this equation. For voltage I1 into Z11. In series they can add, but current is different here. So I take a dependent source. Here also I2 into Z22 and Z21. Here you can connect Zg and your Vg. So if you want VTH here, what to do? Make I2 0, VTH equal to Z21 into I1. That is Z21 into, what is I1 if I2 is 0? Vg by Zg plus Z1. Like that we can find the network equivalent by using your Thevenin's, what we call Z parameters. So there is last concept here is, you can try this interesting question as homework. Try using ABCD parameters. So interconnection of the two-port networks is, if the connections are series, overall Z parameters will be equal to ZA plus ZB, sum of individual, provided this branch should not have any resistance. Parallel connection, overall Y parameters will be added. And cascade connection, we call T parameters will be equal to product of individual T. And series parallel H parameters will be added. And there is another condition called parallel series. Parallel series, G parameters will be added. How do you remember this? Very simple. In here V1 is, and here I2 is same. The V1 and I2 are the dependent variables of G parameters. Okay. Similarly, series parallel, if you have, what is this? Series parallel. Input current is same, output voltage is same, which are the dependent variables of H parameters, they will be added. Similarly, for series connection also, current is same, which is dependent variable of Z parameters. For parallel connection, voltage is same, which is the dependent variable of Y parameters. We can prove it also. So that finishes 3 chapters. Tomorrow we will discuss the very important topic of transient and AC analysis. Okay. So our new batches are going to start, guys. So अभी तो बहुत ज़्यादा discount मिल रहा है आपको. 15,000 इसका फीस है. So early bird offer पे आपको coupon use कर सकते हैं. Yes, GATE 35 and you will get for just 6,011. Okay. And this is for batch here 2 times. There is another batch for 28 aspirants that comes out at around 11,034. This is a 2 years course. Both are available. You can, if you have in case of any queries, you can just log into our Telegram channel or website and you will get more, you can ask the more details. Thank you all. We will be meeting in the next session. If you have any queries, you can ask me. Otherwise, we can leave. Thank you. Yeah, I will take the PYQ series also. For one. Okay.